Hey there, today you're going to make a game. By the end of this video, you'll know how to build a game just like what you see on screen. Even if you've never looked at a line of code or thought about building your own game before, you'll end this video knowing how to build a game of your own. We'll start with how to get set up, what tools you need, and how to install them. Then we'll dive into art and see just how easy it is to pull any art you want into a game. Next, we'll move on to coding in a way that's easy enough for a 10-year-old to understand, and by the end of it all, you'll be able to customize like crazy and just have fun with your own project. Before we get going, I just wanted to say that if you have questions, drop them in the comments below. I'll be watching them and try to keep up with them and answer whatever problems you might come up with. Also, if you don't mind, please hit that share button if this is the kind of content you're interested in, where we do in-depth tutorials on game development. It really helps when you share it, or at the very least just hit the like button. And also, if this is a little bit too beginner for you, you're looking for more advanced stuff, I'd say hit the like button and skip to the end where I talk about how we're going to turn this into something a lot more advanced that probably fits your needs more. All right, let's get going. We're going to start with installation and setup. We're going to begin with installing Unity, so if you already have Unity installed, go ahead and skip past this part. But if not, let me explain briefly what Unity is, why we install it, and how to get it installed. So when you're building a game, what you'll usually do is start with an existing game engine. Unity and Unreal are the two most popular game engines, and most of the time, as a developer, when you're starting up a game, you'll pick the engine that you like the most or you're most familiar with. Now you can build the same kind of games in Unreal, but we're going to do it with Unity today. So to get started, what you need to do is go to the Unity download page. That's just at unity3d.com/download, and it'll redirect you to something like this. You have two options here. There's a choose your Unity plus download, which is to install a very specific version of Unity. So Unity releases about 4 new big versions every year. And if you want to install a very specific version, like I want the version from 2018 Q1, I can go there and just choose it and install that. But what I personally prefer, and most people that I know use, is the Unity Hub. This is a tool for managing your projects and managing your different Unity installations. It doesn't matter necessarily which one you go with, but I'm going to go with the Hub and show you that process, and you can just follow along. So we'll install the Hub, just click on it to download it, and it's going to go right into my downloads folder that I've emptied out so it looks nice and clean. When it's done, I should see it in my bar in Chrome or whatever browser you're using, or I should be able to just go to the download folder and see it right there. Now we'll install it by double-clicking on the installer, which is going to pop up a little dialog, a user account control dialog in Windows. Just click yes on that. And then choose agree to the terms of service, and we'll go for the default installation folder. Hit install and let it finish. When it's done, we'll choose run Unity Hub. And then when the firewall pop-up appears, just allow access to it. Once the Hub launches, you should see an app that looks something like this. There's a projects, a learn, and an install section. We need to go to installs first, and then choose add to install a version of Unity. Right now I have a bunch of versions installed, but you'll probably have none. So hit the add button and then choose the latest official release. You can see the version that it currently is on, but it doesn't matter if it's a newer version. Just select that and then choose next. And you'll see here that we have a bunch of options for different types of build support. So if we wanted to build for Android and make a mobile game, we'd just choose that mobile box and click it to install that setup. We could also do the same for WebGL. So if you maybe want to share this game on the web when you're done, choose that box. Otherwise, you can just ignore most of these options and hit the done button. Then it will do an install. You see that if we've run out of space though, it's going to give me an error and say, hey, we don't have enough space available. If that's the case, then just go clear up some extra hard drive space on your system. How you do that, I think is kind of up to you. I personally like to use the WinDir tool to find extra stuff or just delete things out of the temp folder. Assuming that you are not out of space though, your install should finish and you'll get a version like this showing up right here. The next thing we need to do is create our project. To do that, we'll go to the project section, and then we're going to choose the new option. Since I have multiple versions of Unity installed, I'm going to use the drop down and choose the version that I want to use. If you only have one installed though, you can just click on the button. Next, we'll choose a template. I'm going to use the 2D template because we're going to build a 2D game, but it's worth noting that if you accidentally choose the wrong one, it's pretty easy to switch back and forth once you're in the editor. It's really just setting up some defaults for the way the editor looks and the way that our camera is set up. They're pretty simple things to swap back and forth between or even mix and match. Next, we need to look at the location. I store my game projects in this Git folder just because I use the Git source control system. I recommend that you create a projects folder or something else off of your root folder on your main hard drive, whatever your fastest hard drive is really, and keep all of your projects in there. When we create a new project, it'll be a subfolder of this. Don't mix it deep into your documents folder or your downloads folder where it's going to get lost, deleted, or just confused with something else. Keep a nice setup or area for all of your projects. Now we need to give it a name, and I'm going to name this Mad Birds, and then hit the create button to kick off our project. Now starting up the first time may take a minute or two, so just be patient and wait for those little loading bars to go by, and eventually you'll be presented with a UI that looks just like this. Well, here we are, we're in the game engine, so what do? Well, first, let's make sure that your layout looks like mine so it's not confusing. To do that, go to this window option, and then look for layouts and just choose default. We'll use the default layout throughout this entire thing to make sure that it's consistent and easy to follow along with. Now, go over this scene view. You should see here that we have a scene, a game, and an asset store tab. We're going to ignore the asset store tab for now. We're going to go back to this scene tab and then put our mouse over this scene area where we can see a little camera icon and a grid. If you use your mouse wheel, you should be able to zoom in and out just like this. And notice that it's going to zoom in and out based on where the mouse is. So if I move it over there and zoom in, it's going to go there. If I move it over here, it's going to zoom in on this spot. And if I just zoom out, I'm going to get into this weird, odd position. Now, if I want to drag this around so that I can see the camera back in the center, I can hold down the right mouse button over the scene view and move the mouse. That way I can just drag it and move my view all around. Then I can zoom back in. What I want to do is get it so that this box right here that's showing me what our camera can see is all in my scene view and visible. Now, when I say that this is what my camera can see, what I mean is that we actually have a camera component in a level right now that's able to see something in our game view. So if we click on game, you see that we have a blank blue screen. What's happening is that we actually have a camera set up, but we don't really have anything for it to look at. Let's see how we can modify that. I'm going to go back to the scene view, and I'm just going to left click on this camera. And notice that in our scene hierarchy, it expanded and our main camera got selected. If I click off of it down here, you'll see it's unselected. And if I click it again, you'll see it's now selected again. So we have our main camera selected, which is this camera that's showing up here and this box that's showing what our camera will show our player. And we also get a little camera preview. Again, still just blue because we haven't put anything in front of it. We also have this inspector tab that showed up and gives us a couple options. We have a checkbox to allow us to turn our camera off and on again. So we can just toggle it on and off by clicking on it. We can rename it just by typing in here, call this main camera 2 or something. I'm going to undo that though. We can also adjust the position, rotation, and scale of it. So if I grab the rotation, you can see that I can do some weird stuff. It doesn't make a lot of sense though when I grab this X and rotate it. So I'll put that back to 0. Let's try moving in the Y value. So I grab the Y here and I go left and right, and you can see that the camera goes up and down. And if I rotate on the Y-axis, it's a little bit weird too, but if I rotate on the Z-axis, it might start to make a little bit of sense what this rotation is doing, right? We're tipping it left, or I guess right or left by dragging this up and down. And again, to drag these, just click on them, and then hold the mouse and drag left and right or up and down. Now I'm going to reset these all back to 0 just by clicking in the box and hitting a 0. We're going to leave the Z at -10 though. That's the default value. I'm going to put the Y back to 0 though. Make sure that everything else is 0 and our scale is still at 1. There's really not a lot of point in scaling a camera, by the way. We'll play with scale a bit later though. Okay, so we have our scene here and our main camera, and our level right now is called sample scene. First, let's just try adjusting the background color of our camera. To do that, we can click on the background. Again, we need to make sure that our main camera is selected. We click on this background color and we get a nice little color picker where we can go choose a color for our background. And if you look here, we can see in our camera preview that it's updating. And if I go to my game view tab here and then click on this background, you can see that we're actually able to update it and see what the game view looks like while it's updating. I'm going to go with something that's kind of a dark green for now. We'll change it later though. So go ahead and just choose any old color that you like. Make sure that you understand how we change that color. Now we're going to create our first sprite. To do that, we'll right-click in the hierarchy area and then choose 2D object because we want to create a new 2D object, and then choose sprite. We should see a new sprite appear in our hierarchy, and our inspector should update to show us info about our new sprite. The first thing that I want to do is change this actual sprite value under the sprite renderer. You see that it says sprite is set to none, and it's got these brackets around the word sprite, meaning that it wants us to assign a sprite here. Now if you don't see this and it looks more like this, it's just because it's collapsed. You can click this little arrow to collapse and expand each individual section of our hierarchy or our inspector. Now to choose a sprite, I can just click on this little circle option here, and it'll show me all of the sprites that exist in my project so far. Right now we don't have anything really interesting, so let's just go with the knob sprite. So I've chosen the knob sprite, and you notice that we can't really see anything in our scene or in our screen at all. Now what's happening here is that when we created a sprite using this right-click menu, the position of it wasn't really well known. It just kind of assumed that we wanted it in the center of our screen, kind of back somewhere. It didn't know what position to set it at. So to fix that, we can right-click on our transform here and choose the reset option. All that's really doing is setting the X, Y, and Z to 0, the X, Y, and Z of the rotation to 0, and the X, Y, and Z of the scale to 1. So just resetting these back to the default values. Now if I go to my game view, you can see I have a tiny little knob right there in the middle. Now let's say I want to make that bigger. I can go to my scene view and I have a couple options here. If we look up here, there are multiple tools available. We have a hand tool, we have a move tool, which allows us to move the object around. We have a rotate tool, and then we have a scale tool. We'll get into the other tools afterwards. But first, go select the scale tool, and then we'll zoom in with the mouse window a little bit. And notice that we can't really see it, but there is a box here underneath this camera. So if I grab this box and just drag it up, you can see that our little knob is growing and growing and growing. Now I'm going to move to the move tool by clicking on it up here and just drag it over to the right a little bit. Now if I switch back to that scale tool, I think the dot shows up a little bit better, and I can scale this thing back down, and we still can't really see the dot very well, but it's at least somewhat more visible because we don't have the camera on top of it. Now let's go to the game view and see what that looks like as we've scaled it. Also notice that these scale values are changing every time we've dragged the scale up and down. All that's really happening when we use that scale tool is these numbers right here are getting increased. So if I just grab on this red though, notice that I'll stretch it out to the right and only the X scale is growing. If I grab on just the top one here, this green one, only our Y scale changes. Now, it's also worth noting that it's scaling our Z value, but our Z value doesn't matter at all because we're flat. The Z value is the depth of this object. Since it's a completely flat object, its scale doesn't matter because no matter how deep we make it times 0 for the actual depth, it never gets any deeper. Imagine it's just like a 2D flat piece of paper. Doesn't matter what we do on the scale on the Z because it won't scale out there. But we can scale it on these X and Y values. We can also go to the game view and just grab these values and scale them up and down. It does start to get a bit blurry though. This sprite isn't really made for scaling up and down. So let's set it back to 1, 1, and 1 and just leave our little sprite right there. And then let's talk about how we can replace this with something that's not a boring little dot. When it comes to finding art for your game, there are dozens of places available with free or cheap art that you can download and just pull right into your projects. When it comes to building 2D games, you can really use almost any 2D image. The one thing you'll need to think about is transparency, but we'll talk about that more later. To get started, what we're going to do is use this opengameart.org site. They have a lot of great options for 2D game building, and it's all free for us to download and grab. And there's just, again, a lot of selection, so you can pick and customize what you want to build here. Now, to find what I want, I'm going to go to this search box and just choose Bird and hit search. It just autofilled because I've searched for the word bird on here a bunch of times. You can see already that there are many pages of different birds that look like they would fit into this game. I'm going to go with this green guy because he's the one that I tested with. So to download him, I'm going to click on him and it's going to take me to another page. And this page will usually have a list of files available. Sometimes it'll be a zip file that contains multiple textures or multiple sprites for our character. Sometimes it'll just be a PNG file. In fact, let's go just click on another one and see if this one looks maybe a little bit different. So here you'll see that this one has a PNG, another PNG, and a blend file. This is a 3D one, but there are a lot of different things that you might see when you're looking at your 2D ones. In fact, let's go click on just one more and see what these guys look like. Thinking that they're probably going to be a zip. Yep. So these ones that are a zip file tend to be animated sprites that have, the wings flapping or something like that. So let's go back to this green one, and I'm going to download this Flappy Fat Bird Sprite Sheets.zip. That's the name of it. So click on it and download this into my downloads folder. Now that's finished downloading, I should be able to open the file up and go into this PNG subfolder here and see all of the different frames. I can even double click on them to open them up in a viewer, whatever your photo editor or viewer is by default in your operating system. Should just pop up and show them to you. So to get these files into my project, there are a couple options that I have. Normally, if they were just in a folder and not in a zip file, I could take them and I could just drag them into the project. So I could get rid of my browser and I could just take them right here, select all of them. I just clicked on the first one, held shift, clicked on the last one, and I'd usually be able to just drag them over. But if you notice here, I'm getting this little crossed out, you can't do that icon. The reason for that is that they're in a zip file. So the ways around this are pretty simple. I can either extract this zip file, so I can go to downloads, right click on it, and then use extract all, or 7-zip is the tool that I prefer, but I can just hit the extract all option, hit extract, and then I'll get a folder that has them that's not a zip. I can go into that PNG subfolder and I can select them all and drop them right into my project just like that. Notice they've all just appeared in my project. Now, if you don't want to do it that way, you can also right click on this folder, hit show in Explorer, go into the assets subfolder. Notice that this is my git/madbirds folder. Like I said, I put all my projects in that git folder and madbirds is the project name, so that's the subfolder. If I go into this assets folder, this is actually a direct mapping of what we see down here in this project view of our Unity editor. So here you can see I have all of these PNG files and these .meta files. Don't worry too much about those files. We'll talk about them a little bit later. They essentially just store some metadata about how we want to import these images. So what I could do, again, is go into here and then copy from that zip and paste into here. I already have them in though, so I'm just going to close that out and work with the files that I have in my assets folder now. So let's say I want to take this bird and I want to put him into my game. What do I need to do? Well, I could start by just taking him right here, clicking, and dropping him into my hierarchy. And look at that. I now have a big giant bird appearing in my scene. Let's go to the scene view and say I wanted to scale him down. First, I'll click on the scene view and I'll zoom out with my mouse wheel. And then I'm going to hit W to switch to that move tool. Watch, hit W and it switched to the move tool. I could alternatively just click on it. But I'm going to hit it just so I can drag this guy over a little bit and then go back to that scale tool, which by the way is the hotkey E. Or no, not E, R. R is the scale tool, E is rotate, and W is move. So go to R, that's the scale tool, and I can now see that box really easily, the one that was hard to see on that blank white sprite, and grab it and scale him up or down, make him bigger or smaller. And if I scale him down like this, go to our game view, you'll see that we now have a scaled down version of the bird. He does look a little pixelated, but we'll address that in a moment. So right now I've got a bird and a sprite that does nothing. And I want to change this up because I have all of these cool little frames for my bird, but I don't have any way to make him animate yet. I haven't set him up to animate. So to do that, I can actually make a very small change. Instead, what I'll do is select this frame 1, which is our bird that we dropped out there in our hierarchy, and I'm just going to hit delete to kill him out of the scene. In fact, I'm going to do the same for this new sprite. Go select it and hit delete. So now all I have is my main camera. Now I'll select frame 1 here in our project view. By the way, if you don't see the project view, just go to project here. It's on a tab with the console, so you may have tabbed over. So on the project view, I'll select frame 1. Hold shift and select frame 8. So all of them are selected. Now if I drag this into my hierarchy, I'm going to get a pop-up. And it's a kind of an interesting and weird pop-up, but it's saying create new animation, and it wants me to give this an animation name. So I'm going to call this green bird, and it's going to automatically add the .anim extension here. What it's actually doing is creating an animation for us across all of these sprites. So it's creating an animation that will play all of these sprites for us kind of automatically. It knows what we want to do and it's making it so we don't have to do the hard work. So I've given it the name, I hit save, and now I've got my frame 1. I've got this sprite renderer over here that shows frame 1, but it also added this animator component here. And we got this little green bird animation file that appeared. So let's hit play. We haven't hit that yet. Let's hit the play button and see what our bird does. And look at that, he's playing his animation and flapping his wings. So before we move on and start adding more to this, let's talk about how this is working. How is he animating? How did that magic all just appear? Because you're going to want to know how to modify this and make other things animate in different ways. So remember how I said that when we dropped all of these out, it created an animation and we gave it that name? That's this little green bird animation file right here. And if I double click on it, I'm going to get an animation editor window. So if it appeared off screen for me, yours may appear somewhere else. It probably isn't attached. So let's just take this animation window, drag it onto your screen, and then I'm going to dock it right down here next to this project and console window. So now it's a third tab. All of these windows in here can be docked and attached to each other like this and moved around and rearranged. So I've got my animation window on here. I'm going to stop playing for a moment, and I'm going to select this frame 1. This is my bird. And if I look through here in this animation window, I have a couple options. I can step ahead, next frame, like this. Look, and watch what happens to the bird. Again, I have to have him selected for this animation to play on him. So I select it, I can just hit play through and see each frame, or I can hit the play button and just watch it go. I can also go over this part of the animation editor and use the mouse wheel to zoom in and out. Notice how it has 1, 2, 3, 4, 5, 6, 7, 8 keyframes. And if we go back to our project view, we have 8 frames here. What it actually did is it created an animation and it assigned each frame of this to be one of those animation frames. In fact, look at the sprite renderer as I go through this. See the frame number changing? All this animation is doing is saying, hey, sprite renderer, every time we go to the next animation frame, change to the next sprite frame. So we can have animations that do other things, that scale objects, move objects, rotate objects, or even move them around relative to each other in the world. But a very simple and starting animation type is to just do this sprite replacement. So we swap out the sprite every frame, and we get this nice, cool, flapping bird effect. Now let's talk real quickly about this animator, because the way that this animation is hooked up to this is through an animator. And it's a little bit confusing because we have an animation window and an animator window, and I think it's easy to mix them up. The way to think about it, though, is that the animation is a single animation. It's like a single type of thing that's happening. For our bird, we're only going to have one animation. It's going to be very simple. But if we had another thing that maybe switched animations, think of a character that runs and then he switches to a shooting animation or a jumping animation, or maybe a taking hit animation. If we have something like that, we'd be modifying multiple animations in our animation editor, and then we use our animator to hook them up. So let's go look at the animator now. I'm going to go back to the project view, and I'm going to look at this animator and just click on the controller. Notice that it selects this frame 1 controller. This is actually a dot controller file. You can see the extension down here, and it got the name from the name of this bird frame. So I'm going to rename this. I'm going to click on it, just one left click, or hitting F2 on it should pop up the rename dialog. I'm going to rename this green bird. It's going to be my green bird animator. In fact, I'm going to go into my scene hierarchy right here and rename frame 1 to be green bird. That way we can keep it a little bit consistent. Now I'm going to go to this animator controller. Again, not the animation. We already looked at that. We're going to go into the controller and just double click on it. And we're going to get that other animator window. In fact, let's pull up the animation window side by side. Animation has our keyframes. Animator has this weird state machine thing. So the first thing I'm going to do is just grab this green bird section and drag it down so that it's a little bit more in the center of our screen. And then we'll talk about what this is. So an animator state machine is a way for us to transition between different animations or different animation types. Again, if we want to go from flying to crashed or exploded or shooting its little bird gun, we want to be able to set that up in here. And we would do that by adding multiple animations and then adding things called transitions between them. Again, since we only have one animation, we don't need to do that. Instead, we just have a default animation that plays, and whenever we enter our animator state machine, our green bird animation is going to play. And if I click on it, you can see a little bit of info about it. It says that the motion here is green bird. That's our animation file, or our .anim file. If I go back to the project view and click on it, you'll see it actually selects that. So our default animation for this animator is just that green bird sprite animation, and it's just going to loop over time. Now the way that we know it's going to loop over time is also, I think, a little bit confusing. If we select the animation though, we'll see that there's a loop time option. When that's checked, it's just going to automatically loop this animation. Now I want to show one more thing. I want to show what this looks like when we're playing. So I'm going to take this animator window, and I'm just going to dock it over here to the side and just put it maybe right about there. So we can kind of watch this window while we play. I want you to see what it's doing. So we play and we select our bird, and when we've got our bird selected, we can actually see the animation playing in progress. This is showing us the progress of that animation along the way, and every time it goes back to the beginning, it's just looping again. So this is how we set up animation state machines. Again, we're not going to go too deep onto these, but I wanted you to at least understand how animation state machines are created and what's all being hooked up behind the scenes when you do this quick little drag and suddenly a bunch of things just work. So if you need to change it or something breaks, remember you can modify which animation is playing right here. You can even adjust the speed and speed it up, or even put it in reverse speed, the -1, which I think is kind of hard to tell with a bird making it -1. His wings are just flapping. I don't know if you can tell the difference, but you can adjust that speed and then swap out the animation and also know where to look if something goes wrong. And again, that's on this green bird. In the animator, we have the controller and the animation. All right, let's stop playing now, and I'm going to get rid of this animator window. In fact, I'm just going to dock it along here so that it's just another tab and I can kind of ignore it. Before we get to moving around the bird and resizing him, let's pull in a background that we can use for reference and scale so we know how big our bird should be and what he should look like. To do that, we'll go back to Open Game Art. We can just search for backgrounds and find something that we like. I'm going to go with this nice free background that has a pretty mountain in the background. I'll download it by clicking on the free mountain background.zip and let it download into my downloads folder. I'll open up that zip again and pull it over and go into this transparent PNG folder, and then I'll just find the full background image, and this time I'm going to import it in the other way. I said before that we could unzip it and just drag it in. The alternative is to copy it, so I'll right click and choose copy, and then I'm going to go into my Unity project. I'm going to right click in my project explorer, hit show in explorer, which would also be show in Finder if you happen to be on a Mac. Then go into my assets folder, and then I'm going to right click in this folder and paste it in. Now remember, you can do this either way. I just wanted to show both ways that you can put files in so that you know you have both options available. Now I'm going to minimize this and go back into Unity, and as long as we're not playing, we should see it appear. If I was in play mode though, this file wouldn't appear until I stopped playing. So now I've got this full background, and I'm going to click on it and take a quick peek at it. With the background selected, we can see all kinds of different import options here. Now, most of the time, you're not going to need to change these from the defaults, but you do want to make sure that it's set on Sprite, 2D, and UI. Sometimes the textures that you'll pull in will be set to default, and you'll need to change them if we're working on 2D sprites. The default mode is more for 3D objects or things that are rendering on 3D objects, the textures that go on top of 3D objects. Think of like the skin for a 3D character or the side of a building. For sprites though, we want to make sure that we're on the sprite mode. Also take a look at the little preview window down here. We can grow this, make it bigger, smaller. You can even right click on it to pop it out, and then you can redock it down here. And if you click this little button, you can actually dock it back to the inspector. It kind of goes off screen though, but if I drag it over here, see that we can hit dock preview to inspector, and we can drag that back over. Also, if that disappears, it could just be that you left clicked on it, which minimizes it. Just left click on it again to bring it back up. So I'm gonna fix my layout because I'd already moved it around a little bit. I dragged this, that's why things look a little bit different. So remember to change our layout back to default. We can go to Window, Layouts, and then Default again. Now I want to take my background and just put it into our level. So I'm going to grab this full background and drop it right into our hierarchy area. I could also drop it right here, but I'm going to put it in the hierarchy just so the position goes to 0, 0, 0. Now I wanted to pause for just a moment because you may have run into something here. It's possible that when you put in your background, you don't see your bird. And that's because the background could be drawing on top of the bird. To control the order things draw in, we use the order in layer setting here on the sprite renderer. And since our bird and our background are both set at 0, it's very possible for the bird to render behind the background or the background to render behind the bird. We're not really controlling it, and it's going to be somewhat random. So to adjust this, you can go to the background and on the order and layer area, just put in a lower number than 0. So we can go with -1 to force it. I also want to show, if you're not seeing the issue, what it looks like. So say I pulled my order and layer up to 1 or anything greater than 0. My bird's just missing. I can select him. I know he's there because I can see the outline and the selection outline, but he's not rendering. So again, just pull the order and layer for your background back to anything below 0. I just go with a nice low number so that the background's always back and not blocking things. Then I'm going to zoom out over the scene view. Make sure you're on the scene view, not the game view, but the scene view. Use the mouse wheel to zoom out, and we can get a good idea of how big our bird is compared to our level. But also notice this little white box here. That is our camera view. So if I go to my game view, you'll see that that's what my camera is showing. If I go back to the scene view, you'll see, hey, my camera is only showing this little chunk here. So what can I do to fix that? There are a couple options that I've got. I can move my camera down, so I could just select my camera, hit W to go to that move tool, and notice the little arrow popped up, but I could also use the Y value here. I'm just going to use the green arrow, and I can drag it down and look at that camera preview. The camera preview makes it nice and easy for me to see what we're going to show in our scene. So this looks closer to what I want to see for a level. The bird is obviously way too big, but if I go back to that game view, you'll see that, hey, I can see the mountains, I can see the ground. I think that's probably good. So let's go back to the scene view. With our camera down in the right position, and if we look at the Y value here, you'll see it's what, -2.39. We could always round this to like -2.4 or -2.5, whatever looks good. And then we'll go select our green bird and scale him down. So remember, this white box, that little box right there, is the outline of what our camera is going to see. So I'm going to take this bird and I'm going to scale him with R, the scale tool, or select the scale tool up here. Grab this little scale dot in the middle and pull down until he looks about the right size. Now, I'm pretty sure I just want to go with a 0.1 here. So I'm just going to go into my transform scale and just type in a 0.1 for all three of these. But remember, Z doesn't really matter, so I can leave that at 1 or 0.1. Now, if I go back to my game view, oh, look at that. My bird looks a little bit closer to the scale that I would expect to see him at. I'm going to go back to the scene view one more time, though. Go to the move tool, which is, again, W for the hotkey, or click on it up here. And then grab it with this little blue box and just put him kind of in starting position. So I expect him to be right about here, remembering that this white line is my camera. I'll go back to the game view, I can see it right there. One thing that's worth noting, by the way, if you have multiple monitors or you have the screen real estate, you can always take your game view and pull it side by side, and then you can see your game view and your scene view at the same time. But there's something weird going on here. Notice how my camera has changed and my bird is no longer in the camera. The reason for that is the game view by default switches to this free aspect mode, which means that it's going to render whatever resolution or aspect ratio fits in the window, no matter how you scale it. So if I scale this thing out, notice that it's getting wider in here. I scale it this way and it's getting smaller. What I actually want to do is change this free aspect option over to something like 1920 by 1080 or 16 by 9 or 16 by 10, whichever one of those you want to choose. I generally go with a 1920 by 1080, but you can choose any one of those as your default. Now, if you don't see 1920 by 1080, you can always hit this plus, and then you can just type in the values that you want. So you can put in 1920 and 1080, and it will become a resolution. You just hit OK and it's going to add that right in there. I already have it, so I'll hit cancel. But you can add in whatever resolution you want, and it's good to do that for whatever platform you're targeting. 1920 by 1080 is 1080p or the standard, so that's usually what I just target. So we've got 1080p or 1920 by 1080 selected. Now we got a better idea of what our thing looks like and where our bird sits in the scene. So I'm going to move him over just a little bit so I've got a little bit of extra room there. Now I think he's in position. So let's say I want my bird to fall. To make an object fall or interact with the world in a physical way, we want to use the physics system that's built into Unity. To do that, we simply need to add an extra component onto our green bird. Now we haven't talked much about components, but let's take a quick peek at the inspector. Notice that we have a transform and then a sprite renderer and then the animator. And remember that the animator only came when we made the animated version of the bird. If we look at our full background, for example, it does not have an animator, just a transform and a sprite renderer. I'm going to go select the bird again though, and look down below at this add component button. This allows us to add more components, more things like sprite renderers and transforms and animators. But we don't want to add two of the same thing. Instead, we want to add something that allows us to use the physics system. So I'm going to hit add component. And if I just clear out my search here, you see that there are a bunch of different folders and options. We want to use the physics 2D section. And it's very important that you avoid the physics section when you're working in a 2D game because it's easy to accidentally misuse and use the wrong component. In fact, building this thing up, I did it multiple times. I still consistently accidentally use the 3D physics things when I mean to use the 2D ones. So make sure you go to physics 2D, and then we're going to look for a rigid body 2D option. So if I scroll down, I should see rigid body 2D, and I can click on it. I could also alternatively just start typing and searching and filtering and find it in that list. If I go to this add component and just start typing, well, let's collapse some of these things and show it. I start typing, I can type RIGI, and you'd see rigid body 2D has appeared. But I've already got it added on there, so I don't need to add it again. So now my bird has a rigid body 2D on it, and before I hit play, I'm actually going to save my scene. To do that, I just hold Control S or Command S, or you can look for it here under File and Save. Whatever your hotkey is there, it should be just Control or Command S though. So now it's saved, and notice there's a little star went away, meaning that my level is saved. My bird, if I go select him, has a rigid body, an animator, and a sprite renderer, and if I hit play, I should see some magic happen. Look at that, my bird just falls and keeps falling. Now, you might wonder, why does he fall and not hit the ground? Well, if you think about it for a moment, we don't want our bird to just randomly hit any sprite that's out there in the scene. We want things to be backgrounds. We don't want him like interacting with that mountain. We just only want him to fall and maybe bounce off the ground piece there. Since we have the ground piece as a single object though, it's going to be a little bit weird because our background right now is a giant picture with the ground here. It's got the mountains in the background and the sky in the back there. So you might think, hey, well, I guess we need to split this up, right? Let's make it into 3 different pieces. Maybe it's the mountain, the clouds, and then the foreground piece. We don't actually need to do that. It's much simpler than that. So let's get the game view back onto this tab so we can have our scene view big. And let's think about other ways to address this. What we actually want to do is set up a collider. Now, a collider can be set on any sprite, or it can be set without a sprite. In fact, what we're going to do is create a collider for our background that doesn't really line up with our sprite. So I'm going to select this full background and I'm going to add a component to it. We'll go to Physics 2D and we're going to look for Box Collider 2D. Now notice that it made a green outline around everything. You might not see it, but if I zoom in, you see this little green outline. If I uncheck the box collider, you see that it turns off. This is showing us what the things will collide with, or what the bounds of our collider are. Now, since this collider is way too big, in fact, it's the full background, and I just want it to be up to here, we're going to need to edit it a little bit. Luckily, we can just hit this Edit Collider button, and then I can take this green dot and drag it down. So I can make it so that the collider now only encompasses this ground part and not the full background. So now if I save and press play again, it should automatically switch to the game view and our bird still falls right through. What's going on, Jason? You lied to me. Why doesn't this work? Well, the problem is that our bird doesn't have a collider. So when we want to deal with collisions in a game, we need to give both of the things that we want to collide a collider. It's essentially saying that this is the hitbox, or the area where if these things touch, count it as a physical reaction. Again, we could have things that we want to pass through walls, or we might have invisible walls, or just background elements or things that you can walk through. I think a lot of games have trees and stuff that you can just walk right through. We could be in that scenario, so we need to be very specific and assign and define what our colliders are. So our bird also needs a collider. So I can go add component, and I could go to physics 2D, and I can add a box collider around him, but that might be a little bit weird because he's not really a box shape. So the collider around him, in fact, let's add it real quick. See that the collider around him doesn't really line up with him well. And it'll land, it'll collide, and he'll kind of slide flat along there, but he should really roll and bounce and hit off of different pieces of him. We can be a little bit more precise with the collider for this. So I'm gonna remove this box collider. So again, I've got the green bird selected. We'll right click on the box collider that I just added and hit remove. We'll go to add component, go to physics 2D again, and we're gonna look for the polygon collider. Polygon collider 2D. And notice that this put a bunch of little green lines around it. It's essentially making a collider around this bird object. I'm going to save my scene one more time and then zoom out with the mouse wheel. And then we'll press play and watch the magic happen. Look at that, our bird has fallen. He's down. So next we need to talk about how we can make him fly. How do we make it so he can launch away and go hit enemies and start diving into actually writing some code. To create our first code file, we can simply right-click in our Assets section, choose Create, and then choose C# Script. It's going to pop up, create a file, and it's going to give us the rename dialog by default. If you click off of it, you're going to get this weird named one like that. If I click off, it's going to be called New Behave, and I might not even be able to read the entire name of it. What I can do, however, is use this slider to switch between a graphical view or a list view. Then I can see it's named New Behavior Script. I don't want that to be the name though, so I'm going to hit F2 and rename it. And I want this to be named Bird with a capital B. And while it might seem kind of stupid, the naming and the case sensitivity is somewhat important. So I recommend you go with the capital B. And I'm going to hit enter. Then I'm going to hit enter one more time. And what should happen for you is your code editor will launch. On Windows, by default, this is going to be Visual Studio. On a Mac, I'm not sure what it is now. I think it might be Visual Studio Code, but it should look very similar, and the code that you write will be exactly the same. So here's what my editor looks like. Now, by default, there are a lot of things visible that I don't necessarily need to see, like this output window. So I'm going to auto hide it just by clicking on the little pin. And I'm going to do the same for my Project Explorer. Sometimes these can be useful when you have a lot of files in there or there's a lot going on in your project, but right now I don't necessarily need them. There's also, it looks like, an update available. I'm going to skip that one for now though. And let's just take a look at our file here. So there are a couple things to notice. The first is that our file up here says it's named Bird.cs, and we can have multiple files here. They'll all show up as different tabs, but the one that we have selected and opened is Bird.cs. But notice here that we have this weird thing that says public class new behavior script, which might remind you of the original name of it. This is actually going to cause a big problem, and I've seen a lot of people struggle with this. We actually need to make sure that the word here after this part that says public class matches our file name, but not with the .cs. So it should just say bird. So to change that, I'm going to double click on it, which will just select that whole set of code, or that whole word, I guess, and then put in bird with a capital B. Again, the casing matters, so make sure that you match it. Then I'll save it with Control S. You can also find your save hotkey by going to File, and then where's it at? Save Assets / Bird, Control S. So now we've got a class file, or a code file, or a script that's made for our bird. And it's got a bunch of weird stuff in here. So let's talk about this and assume that you've never seen code before. Let's look at first the left side. Here we have the line numbers. This is the actual line number of code so that we can reference them when we're talking about them or go to them or when we're looking at error messages. Sometimes we'll get an error message that says error on line 306, and then we can just go here and look for line 306 and figure out what the problem is and maybe try to track it down. Another thing we can do is in Visual Studio, we can hold Control and hit G and then just type a line number to go to. So say I wanted to go to line 16, I could go to that. Not super useful when I have a tiny little file that all fits on one screen, but sometimes if it's bigger, I might need to know what those line numbers mean and how to get around. We can also scroll up and down to look through our file, and well, again, it's kind of tiny, so there's not much there. And then we can click on anything, and we can even collapse these little sections and expand them out. So let's talk about what all of these things mean now. At the top, you'll see that we have 2 grayed out lines and 1 non-grayed out line. They all start with the word using, and then they reference something here. Like this one says using system.collections. The next one says using system.collections.generic. And then the one that's not gray says using Unity engine. What these are telling the editor, or I guess really the engine, that we want to be able to use special methods and classes, which are extra code that somebody else has written, from these packages or namespaces. They're almost like an external package, but it's kind of all bundled in. It's a little bit confusing if we go into the details. You can essentially think of it as a little chunk of code that we want to make available to our code. So we're saying in our bird, we want to be able to use collections, which are things like lists of objects. We want to be able to use generic collections, which are things like lists of birds. We'll talk a little bit more about those later, but we're not actually using them right now, so we can actually delete them. To delete them, I can just go select line 1, hold shift and hit delete, and it should just clear out that line. I can also go to the end of the line by clicking on it, just clicking right at the end. I can hold shift and hit the home key on my keyboard. It'll select the whole line, and I can hit delete, and it'll delete that out again, and hit delete one more time to get rid of that empty line. So now I just have the using Unity engine part. Now let's do a zoom. So if I hold down Control and use the mouse wheel, I can zoom in and out. I'm going to zoom it up so that the code is nice and big. And we're going to take a look at these other parts of our script here. So we have next on line 3, because we deleted that unused stuff, which, by the way, it's just there because a lot of the time those things are commonly used. In our case, we're not going to use them, so there's no reason to have them there and cause extra complication and confusion. But since they're a commonly used set of libraries or methods and classes, Unity just puts them in there by default. So let's look at line 3. Here we have public class bird mono behavior. That's a lot. It means a lot of stuff here, so let's break it down. Now first, the word public here is what we call an access modifier. There are really 3 that you would use. There's private, public, and another one called protected. For our case, we're going to put the word public before anything that says class. Now sometimes you want to make a class that is not public, and what that means is that it can't be accessed or created by other classes. Now again, we don't need that here, and public is what you're usually going to see before any old class. So when you see a class, you're usually going to see this public word before it. But you'll also notice later on that we'll have methods that are public too. So down here we have this void start. We may have the word public or private before it. In fact, if we don't put public here, it implicitly means that it thinks we have the word private here. And again, that just means that this start method wouldn't be able to be called from other classes or other scripts. We'll talk about why that's important later though. So the next thing that we have after the word public is class. Now there are a couple different types of files that we could have. We could have a class file, which is essentially a code script that's going to run some behavior or some actions. We could also have a struct, which is more of a data storage type, where we could have some information that we store on a thing. So we create a file, we create a struct in there, and it just stores some info that we pass around. And there are some performance reasons for that and special uses for it. But again, we're not going to need those here. Right now, we just need a class, and we're only going to use classes. Then we have the name of our class. So here we're saying that we want to create a public class, and we want it to be named bird, or we want to define it. We're not really creating one yet. We're kind of defining what a bird is. The next part is very important and a little bit different and very Unity specific. So every time we create a class, we have the option of using what's called a base class. And a base class just means that we don't want to write everything that this object can do from scratch. We want to be able to reuse some behavior. Now in Unity, if we use this mono behavior base class, it actually allows it to be a component that we can attach to our objects in game or in the editor. Now to set a base class, we have to put this colon here, and then we put the name of that base class. So whenever we create a new script in Unity, we're going to automatically see that it gets created with public class, the name of the script. Remember, I named it that weird new behavior or left it default, so I had to go in and change it. But we'll get the name of the script, and we'll have a colon and mono behavior because it assumes that whatever code we write, we want to be able to attach to a game object or attach as a component. In our case, that is true. There are cases later on where you'll want to write code that's not necessarily a mono behavior, but that's when things get a little bit more complex and I think beyond the scope of what we need for building this game. So we've got this class here set up. I'm going to save, just Control S, and again, double check that the file name matches the class name and that there are no errors. If I had accidentally deleted something here and save, you'll see that we have an error. We've got this little red squiggly saying, hey, it expected an ending bracket. So I need to put a bracket at the end of update because that's what it's expecting. So I'll put that bracket back in, the error goes away, and I should have no problems. Now I'm going to go back into the Unity editor. So I'm just going to minimize my code editor. I'm not going to close it, just hit the minimize because we're going to bounce back and forth to this a lot. We don't want to reopen it every single time. So just hit minimize. We'll go select our green bird. And then I'm going to collapse down this rigid body 2D and collapse down the polygon collider 2D. And then I'm going to hit add component and just start typing the word bird. And I should see my bird script show up. And then I should be able to hit enter or just click on it and have it added as a component. Now, if you don't see it showing up here, you need to go back into the code editor and look for errors. You probably deleted something, added an extra line somewhere, maybe not an extra blank line, but a line with an extra word on it, or maybe you typed the letter K at the end of the file and saved it. That will cause an error. It'll cause it to not compile. So let me clean that up, and let's talk briefly about some of this other stuff in here. So we have on line 5 this green line with 2 slashes, and it says start is called before the first frame update. Now, first off, it's important to note that these 2 slashes just mean that it's a comment. This is code that's not executed. It's just there for humans to read and understand what's going on. It's also a comment that's added by default to every script by Unity so that people who are new can understand what's going on and where to put new code or where to put their code when they're starting up a new project. So the start method gets called before the first frame update. That means that the start method is the first thing that's run on this script. So if we add in some functionality here and we want it to kick off right at the beginning, we can put it in start. What actually happens though is there's an awake method that gets called before that, but we don't need to worry about that just yet. We also have this update method, and it says update is called once per frame. What this means is that every single frame, our code that we put inside this little set of brackets right after this update is going to run. So if we run it 100 frames a second, this code is going to run 100 times a second. If we run it 1 frame a second, it's going to run at 1 frame per second. This is where we put things like input handling, sometimes movement and other stuff like that. Maybe timers, things that need to update every frame or modify something every frame or just do something every frame. Start is where we put things that we need to deal with initialization wise, like setting up an object. So what do we want to do here? Well, first we're going to take both of these and delete them. So I'm going to select from line 5, click and drag all the way down to line 15 and then hit delete. We're going to empty this class out and write it from scratch. We don't need any of that starting nonsense, right? Don't worry, it's not going to be too complicated. Next, we're going to add in a new method. Now, when we use this mono behavior base class, because we have that there, we get access to a whole bunch of interesting and fun to use Unity callbacks. One of them is called OnMouseDown. So if I just start typing OnMouseDown, I should see the OnMouseDown option appear in my IntelliSense, which is the autocomplete option. I can just click on it, just double click it, and I should get a method that gets automatically typed out saying private void on mouse down. Now, if that doesn't work, you can always type this out. You just need to make sure that you have these parentheses at the end, which is Shift 9 and then Shift 0 for the second one. And then you need to have these braces, which are the same braces there, they're the ones next to the P key. So you hold Shift, hit that one next to the P and the one right to the right of that, and you'll get these braces here. They should automatically complete though, and they should automatically add. Like if I delete these, and I hit the opening brace with Shift and the key next to P, I should get a closing brace automatically. Then I can hit enter, and it looks just like that auto-generated section. So what do we want to do on mouse down? What does this mean? Well, this on mouse down method is going to get called every time we click on our bird. It's actually a nice, easy way to handle input onto sprites. So every time we click onto our bird, the first thing I want to do is just change his color. Let's just make him bright red so that we know that we've clicked on him and that we're holding down the mouse on him. To do that though, we need to access another component. So we have our bird component. Let's save real quick and then go minimize this and go back to the editor. And let's look at our bird one more time. So we have our bird component. We have a polygon collider, we have a rigid body, we have an animator, and we have a sprite renderer. Now to change the color, if you're wondering, it's going to be the sprite renderer. In fact, if we expand it out, you can even see it has a color property. And I can click on this, get a color pop-up, and just change it to something else and see what it's going to do. So if I go to red, you can see it turns red. Go to like a green and he turns green, or a purple and he turns purple. So what I want to do is make him turn kind of red whenever we click on him, just so that we know that we've selected him and that we're dragging him. Something that tells us, hey, the system's at least working before we start getting too complicated. So I'm going to change this back to white just by selecting white up here on the top left. And then we'll go back to our bird script. And we're going to say, hey, sprite renderer, when we press the mouse down, we want you to turn red. Now you're probably wondering, hey, how do we do that? How do we access the sprite renderer? Well, luckily, accessing components on a game object is a very common thing to do. So accessing other components that are next to you can be done with a very simple single call. We're using this get component. So we'll type the words get component, and then we're going to use the less than sign, the one shift and the key next to M, and then we'll type in the word sprite renderer, and make sure you spell it right. If you don't spell it right, it's not going to turn blue and it's going to look weird. Then we'll move over one space to the right, so just hit the right arrow on my keyboard, and we'll do an open parentheses and a close parentheses. What this is going to do, this little chunk of code is going to get my sprite renderer, and it's going to let me do something to it. So if I hit dot, I'll see all of the options that I have, and you might notice that color is already an option available. So I can just click on it and maybe hit enter. And then I can say equals color dot red. Now it's important that you match the casing, otherwise things aren't going to work and you're going to have compiler errors. But what we're doing is essentially saying, hey, get that sprite renderer and then set the color to red whenever we press the mouse down. So I'm going to save this, minimize, and go back into Unity. We'll press play and give it a try. So we hit play. We go select our bird, hold the button down, and look at that, he turns red. And if I let go of the button, hey, he stays red. Because we're not doing anything to change his color back. We're just setting it to red and leaving it that way. So let's stop playing, and let's go back into our bird script. Say we wanted to make him not red when we let the mouse up. Well, we can do that just by implementing the OnMouseUp method. So here I'll just add a new line after line 8, and I'll add one more line because in between these methods, I always leave one blank line. And it's pretty much a common standard to have a one line space between your methods. So just add a line there. And again, it doesn't affect the code functionality. It's really about readability. And a lot of writing code is about making it readable by humans. The compiler can read it no matter what it looks like. Make it human readable first, more than anything else. So let's add an OnMouseUp. So I'm going to type it out this time. Say private void OnMouseUp. Again, I could let it use the autocomplete. And then I'll add the brackets there. So again, that was shift and the key next to P right after. And then we'll say get component. I want to just choose this one that has the arrows. I'm just going to hit the down arrow a couple times and hit enter because I'm lazy. And then we'll hit the less than key to get it into those brackets because it didn't autocomplete to the right one for me. And I'll type in sprite renderer. And I'm just going to go down arrow and hit enter to select it. We add those open close parentheses again and do dot color equals, and here we'll just use color dot white. If I save that off and minimize, we should be able to go back in and see our bird change from red to white when we click and release. Or, well, remember, his white, though, is actually a green. Because we're just adding a red tint on top, and if I release, he's back to green. Red tint, release, back to green. So there we go. We now have a bird that reacts to some very basic input. Now we need to make our bird fly. To do that, we're going to need to implement another method. But first, I've reopened my project after closing it, and suddenly my bird disappeared. So I want to show you what could cause that and how to fix it. So let's go take a look. If we look in our hierarchy, we can see we actually have the bird and we have our background. And if I click on the bird, I can see it right here getting selected in my scene view, but in my game view it's invisible, and even in my scene view I only see the box around it. If I expand out the sprite renderer section though, there's actually an option here called order in layer, and this will bring the object behind or in front of other objects that are on the same layer. Since everything right now is in the default sorting layer, to bring this bird to the front and force him to always be in the front, I just need to make his order in layer greater than the background's order in layer. The default for everything is 0, so just changing it to a 1 will bring him up to the front. And this is how you can control what things are behind and in front of other things. So just remember, if you don't see your object and you can select it, and it's a 2D sprite, it may be an order and layer issue. Now let's jump on to making our bird actually fly. Like I said before, we need to make him move first. We want to be able to drag him around and then have him snap and fire off. To do that, we're going to need to go back into our bird script and add in another method. So let's open up the bird script. And we need to add something after our mouse down. First, let's take one more look at our class here. So we have this public class, and everything inside of these brackets is a field or a method. It's either data or something that can act on the bird. If we put code outside of this bracket, it's not going to be part of our bird class and it's not going to work. So we need to add in a special method, another one of these mono behavior methods, and it's called OnMouseDrag. So if I add an extra line after onMouseUp, and add one more because I want that extra space between my previous methods and my new one. And I start typing private void on mo. Now I didn't use uppercase O here or an uppercase M because I'm going to let it autocomplete. So I'm going to go down and select OnMouseDrag and just double click it, and it's going to implement the method. Again, if I put that down here below this line 19, we'd have an error. In fact, let me just show you what that looks like. So I'm going to take this chunk of code and cut it with Control X. Then I'm going to go down here below and paste it with Control V. And look at that, we have an error. We get the little red squiggly saying that, hey, there's something wrong here. And it says that a namespace cannot directly contain members such as fields or methods. What this essentially means is that your methods or fields need to be inside a class. They need to be inside these brackets. So let's undo that. On my keyboard, that's just Control Z a couple times. It just undoes the previous thing that I've done. By the way, Control Y will redo. So I can go forward, and Control Z to undo. It's a great way to fix a little mistake if you accidentally delete something, break something, or you're not sure what you changed. Just hit Control Z a couple times, you can go back, and if it was the right thing, you can hit Control Y to go forward. Okay, so we've got the OnMouseDrag method. You might be wondering what we do here. Just think about it for a moment. What we really want to do is when we're moving this object around, or when we're dragging our mouse around, we want this object to move underneath our mouse. So we want the object to go wherever our mouse is. So the first thing we need to do is change the transform position. So we can get the transform of our bird without using this get component call. We can actually just say transform dot. And then if you look here, we have position, local scale, parent, local position, rotation. So position, scale, and rotation probably sound familiar. Let's jump back over to Unity and just take one more quick peek at that. Minimize this, and look, we have position, rotation, and scale. So what we're going to want to do is adjust the position of this object, or just the transform component of that. So let's jump back over to our code one more time. And to do that, we'll just say position equals, and then we need to give it a position. So to read the mouse position, we can actually say input dot mouse position. We can add a semicolon to the end of that and save, and this is not going to work. But let's see what it does. Then we'll talk about how to fix it. So we're going to set the position of this thing to our mouse's position. Jump back into Unity. And with the bird selected over here, so we can see it in the inspector, we'll hit play. It should switch us over to the game view. We can watch the position here, and watch as I click on this what happens to his transform position. Look at that. It's at 400 and 257. If I move it down here, it's getting close to about a 0 to 0. If I get right to the bottom left corner, I should be able to get it just about to 0, 0. If I go way up here, it's going to go to whatever my resolution is, so 1920 by almost 1080. And you can see as I drag to the right here, it's what, 1920 by 0 on the bottom. And on the left, you might have guessed this, it's going to be 0 and 1080 on the Y, or close to 0. Just look at those position values and estimate and round them, because I'm dragging a little bit outside the edges. What's actually happening here is the mouse position is 0, 0 at the bottom left. So the X value is 0 and the Y value is 0. And at the top right value, we actually get whatever our resolution is. So we get 1920 because it's 1920 pixels across, and 1080 because it's 1080 pixels high, or 1080 pixels high. So we need to actually translate this. We need to change the mouse position, which is in these screen coordinates, again with 0, 0 on the bottom left, and the max values on the top right. We need to convert that into world space coordinates. So remember, if we stop playing and we look at our bird, let's just switch to the move tool. Right now he is at -5, -3. And 0, 0, if we set him to 0 and 0, is actually right in the center of our scene. It's right in the center of our world. So we need to be able to translate these screen space coordinates into world space coordinates. We also need to remember that not everybody's going to play at the same aspect ratio or the same resolution. So we can't just hard code this stuff. We need to use the built-in helper methods that really make it easy. I'm going to undo that move, by the way, with Control-Z, because it works in the editor just like it does in the code. And then we'll go back into Visual Studio and we'll make a little change. Instead of setting it to the mouse position, we're going to use this special method. And we're going to save off the desired position in what's called a vector3. So we'll say vector3, which is just an X, Y, and a Z position. We'll call this new position equals, and then we're going to say camera.main, casing again matters here, dot screen point to, or screen to world point, sorry. Screen to world point right here. So we're going to select that one and do an open parentheses, and then we give it a mouse position. So what this is doing is we can take the screen space position, transforms position from screen space into world space. So we're going to take this screen position of our mouse and we're going to turn it into a place in the world using our camera. So our camera, knowing where it's looking and where it's positioned, it already knows that, can figure out where in the world we're clicking or moving our mouse when we have this screen point that we give it. So I'm going to cut this input.mouse position with Control X because I don't want to retype it. Then I'll click right here and hit Control V to paste it in. Again, you could always just delete it and type it, but I like to use shortcuts like that. Okay, then we'll go to the end and add a semicolon because we have to end every line of our code with a semicolon. So now we're getting a new position, and we can say transform.position equals, and I'll just type in new position. So we're creating this new position vector here, and then we're setting our transform's position to that position. We could also alternatively do this. Now don't do this right now, I'm just going to show you how it could work. We could say something like this and delete that. And then we're getting this position, it's returning it back over to us, and then putting it in here. We're not going to do that though, because this also isn't going to quite work. So let's undo and get back to this point right here where we have this new position variable. We're going to go in and run it again and see what happens and see why this doesn't work and the last little change that we need to do to make it actually happen. So we jump back to Unity, hit play. Watch this bird's position when I grab him, the X, the Y, and the Z value. So I click, and his X and Y values seem pretty reasonable. If I'm right in the center, it's close to 0. And we're at 1-ish. If I was good at moving things around, I could get to 0. But look at the Z. The Z value is -10. Now the reason for that is that our camera's Z value is also -10. We don't want that. We don't want to be moving the Z position of this object. Let's take a look at this with the scene view side by side with the game. So here we are in the scene view and the game view, and if I move it around or I click around, oh, I've actually lost my bird. If I click around though, you're going to see that the bird is still there, but he's way off position. So I grab him, and look, I can see him in my scene view, but because he's so far forward, my camera actually isn't rendering. Let's go to 3D mode now. So if I click on my scene view, there's a 2D, 3D toggle button. This lets me switch between 2D and 3D mode. I'm going to go to 3D mode, hold down the right mouse button, and just use A to slide over to the left. And then I'm going to stop playing and start playing again. Again, just hold down the right mouse button over the scene view. You can use WASD to move around. So I'm going to do that. I'm going to get a little bit closer to this bird. I'm going to go select the bird. I'm also going to select the camera though. I want you to see the camera's bounds. The camera is rendering everything inside of this box that it sees. It's facing that direction, rendering everything it sees in the box. Now if I go select this bird over here and grab him, look at that. He bounced right over to the edge of the camera. So he's right up against the camera. He's too close and we don't actually render it. So we need to make one more change and just not move this bird's Z position. So instead of it being at -10, we'll leave it at 0. To do that, we'll jump back over to our code. And then instead of setting our position to this new position, we want to set it to this new position, but only the X and Y values. And we want to leave the Z value alone. To do that, we can say the position equals a new vector 3. And let's just delete that real quick. So we do new vector 3. And if you look here, I hit the down arrow once. It actually allows us to just pass in an X and a Y value. And it will set the Z value to 0. So we can do that just by saying new position. I'll hit down arrow and do .x, and then we pass in new position .y. So this is going to give us a new vector 3, but it's just going to have a 0 for the Z value. So if we save that and we come back in, we should see the magic of being able to drag our bird around and get him ready for a launch. Let's play, and we click and drag, and look at that. He just moves around and follows my mouse exactly how I want. Now that the bird follows our mouse around, we need to make a little change so he stops just falling to the ground. To do that, I'll stop playing and we're going to expand out the rigid body 2D component and just set the gravity scale value to 0. This is going to make him not use gravity and not fall on his own. We're eventually going to turn this back on in code, but you can see now I've turned it off and I drag him and he just moves to wherever I drag him. So let's talk about launching this bird. To get him to launch, in fact, let's get the game view bigger. To get him to launch, we're going to pull back and then he's going to fly off in the opposite direction that we've pulled him. To know what direction we've pulled him though, we need to save off this starting position. So we need to know where the bird is when our level first loads or when our bird first gets initialized. Now, I think I mentioned earlier that there's a method that gets called whenever an object is initialized or loaded into a scene, and that's the awake method. There's also a start method that gets called a little bit later. In this case, though, we want to use the awake method to just save off the starting position of our bird where our bird is placed, and then we'll use that in a calculation to tell our rigid body, this little component here, to make our bird go flying off in the opposite direction or towards that starting point is really what we want. So imagine we pull him down to here, we want him to fly towards that point. If we pull him like this, he should fly down towards that starting point too. So let's go back to our code. And we can add a new awake method right at the beginning of our bird class. Most of the time, the way that I'll organize these methods is I'll have the awake and start right up at the beginning of our class. I will put some fields above that, and you'll see that shortly after, but I usually try to avoid having my awake and start methods in the middle or near the end of the class. I want it to be very obvious for anybody that opens up this code that right when it starts up, it's doing something, and this is what it's doing. So let's add an awake now. We'll add a line after this line 4, again inside the brackets, very important to be inside our class. And just start typing AWA and it'll autocomplete, and I'll hit down arrow and enter. Again, you could also type out private void awake, open parentheses, close parentheses, and your brackets, but you got to make sure your casing matches. So in our awake method, we're going to save off this initial position, and we're going to do that in a variable. We don't have a variable defined yet though, so we're going to add one now. In fact, we're going to do that above our awake method. So I'm going to go up above awake again, hit enter a couple times, 1, 2, and then I'll go up here to line 5, where I'm on the first line after the bracket, but I've got another extra line after it, just so that it's a little bit easier to read. And we're going to say vector 3 with a capital V. That's this type of an X, Y, and a Z position. And we're going to name this with an underscore. So the first character is going to be shift and the key just to the right of 0 to give us an underscore. And this isn't a hard requirement, but it's a very common naming practice, and I recommend that you follow it. And we'll call this initial position. with a lowercase I and a capital P. So this underscore here is really just to define that this is a private variable that should only be accessed inside this bird class. It shouldn't be accessed by anything outside of this bird class. And remember, I mentioned earlier with the accessibility modifiers, you can put private here, or you can leave it blank and it means the same thing. If you put public here, suddenly this underscore wouldn't make a lot of sense and we would be able to access this thing from outside our bird class. We don't have any other classes, so it really wouldn't break anything right now. But as our projects grow, we want to make sure that only things that are meant to be modified by other classes can be modified by those classes. So we keep this private and use the underscore as a convention. And then in our awake, notice as I start typing, it's already going to start auto-completing. It's found our variable there and it knows it's there. But I can type IN and kind of filter it down even more. And then just hit enter. It's going to give me the initial position. What we're going to do is set this to a value. So we'll say equals, and then we'll use that built-in transform component. So you say transform with the lowercase t dot position. So when our bird first starts up, we're just going to take the position that it's at and save it off into this variable so that we can reuse it later. Again, we're going to be moving the bird around, so this transform position won't be in that initial position ever again unless we force it back to that position. So this also gives us a nice place to reset the bird. Say we want to reset our bird after we've launched him and he's died and we want to reuse him, we can just drop him right back to the initial position. So we've got our initial position saved off. And now we're going to go down to OnMouseUp, because in our OnMouseUp, that's when we want to launch the bird, right? So we pull him back, we release the mouse, and he goes flying. This also, by the way, applies to fingers. We could pull him with our finger and release, and he'll go launching. Counts just like a mouse does. So to make him go flying, we need to access the rigid body component. So just like we got the sprite renderer, we can say get component. And then we say rigid body 2D, we have to use the 2D one, open and close parentheses, and this is again just going to return that rigid body component to me. And then it's going to let me, by putting a dot at the end, just do something with it. So I'll say AddForce, right there's the first option when I type AD. Then we do open parentheses, and AddForce takes in a vector. It allows us to give a direction and a magnitude. So I can say add force in the upward direction, which would be a vector that only has a value on the y-axis and has 0 on the x. If I did one just on the x, I'd be moving horizontally. If I do one on the x and y, then I'm going whichever direction the x and the y are facing. Just think of it kind of like a graph or a line graph with the, the x and the y. Hopefully that makes sense. But we're going to add force in the direction to the initial position. So we want to figure out the direction to this position and add force in that direction. So we need the direction. We don't have it yet, so what I like to do is just type direction to initial position. And then I'll add a semicolon at the end. And direction to initial position doesn't exist yet, so we're going to create it. There are a couple ways that I can create this. I can just add a line right up here and start typing it out, say vector 3 and direction to initial position equals whatever, or I can hit Alt-Enter on it. So I can select it and hit Alt-Enter and then choose the generate local option. Or it's actually a vector 2. I said vector 3, didn't I? So generating really helps. So this gives me a vector 2, which is just a two-dimensional vector, so we don't have that z value. And right now it's setting it to the default value. That's not what I want. I want it to be the difference between our initial position. So I say initial position minus our current position. To get our current position, that's the transform dot position. So now we're getting the direction to that position. And this isn't just the direction, by the way. This is the total distance or the total movement amount. So if we've moved over 10 on the x-axis, we've drug them way over to the left, and we move down 3 on the y-axis, we're going to get a, whatever it is, -3 and -10. So we'll have -10 on the x and -3 there. Or we should be getting the inverse of that, actually. So what we're going to do now is add force in that direction to the position. So let's save this off and go back into Unity. We'll play and we'll give him a launch and see what he does. So we drag and we release, and you might see it, he's slowly kind of moving upright. You can kind of see it in the direction. Let's stop playing and try it one more time. So now I'm going to take him up this way and pull him really far and let go. And you can see he's kind of moving down this other direction. So he's moving towards the initial position, but he's not going very fast. I want to speed this up. So I want to take the amount that I've moved him and multiply that before we apply the force. So we'll go back into our bird script. And what we're going to do is I'm going to add another line here after 21. And we'll zoom, or we might not need to zoom in here. I'm going to take this direction to initial position and I'm going to multiply it. So to multiply, we just add a star, which is Shift 8. And then we'll multiply it by a value. Let's just say we want to multiply it by 100 now. So he's going to move 100 times faster than he just did. I'll minimize this, go back in and hit play. And pull him down and release, and look at that. It's getting closer, right? He's flying off, but he's also not falling. So he goes flying, but he doesn't do that whole arc where gravity is pulling him down. And remember, that's because we set the gravity scale to 0. So how do we fix that? Well, we can go back into our script, and we can just tell our rigid body to set our gravity back to 1 once we release. So we'll get our rigid body again. And then we'll say gravity scale equals 1. So now we're setting that gravity scale back up to 1. By the way, this is a little bit of an issue, and we're going to talk about this in a little bit. We don't really want to keep getting the rigid body constantly, but it's not a huge deal right here because we're only doing it whenever we launch. If you see a lot of stuff about calling get component is slow, calling get component can be bad, that's true. But when we're just in a mouse up situation like this and we're keeping it simple, it's not going to make any difference at all. So don't worry too much about that. Just know that we're getting the rigid body, we're telling it to add force, and then we're getting it again and telling it to set our gravity scale back to 1. So let's go back to Unity, try one more time. Grab our bird, we release him, and look at that. He goes flying and rolling. I grab my bird and release him, and he got all weird and buggy because he's not actually resetting. Let's try it one more time then and see if I can launch him really far. So I'm just going to pull down like this and launch him up. Oh, still doesn't go very far. Now let's talk briefly about resetting our bird. Say we've launched our bird way too high off the screen or way too low, or maybe let's go to our scene view and switch back to 2D. Maybe our bird has flown. I'll grab him and he's way over here somewhere or down here. Kind of gone off the screen. We want our level to reset and our bird to reset. Or maybe our bird's even just sitting there, kind of floating, rolling on the ground, and he's stopped and he's hung out after we've launched him. We want to be able to reset and relaunch our bird. So I'm going to move him back into position. And then what we're going to do is go back to our bird script and write another little bit of code. So we'll go into our bird, and right after the awake, we're going to add in one more special method. And this is a method that you're going to use all throughout your programming career, at least while you're in Unity. And that's the update method. So I'm going to start typing UP and see update automatically appear and hit enter to fill it in. So the update method, this is the one that was commented initially that we cleared out. And it says it's called once per frame. Again, this means that if we're running at 100 frames a second, this is going to get called 100 times a second. If we're running really, really slow on some super old piece of hardware, 1 frame a second, we're going to get this once per second. Or if we're under a frame a second, we'll get it even more rare. Usually, though, we should be targeting around 30 to 60 calls to our update every second, running at just 60 frames a second. It's pretty standard. So I would expect that this is getting called a lot, especially in our current scenario where we don't have much going on. So we'll need to take that into account as we build this up, but not too much. What we really want to do here is do a check for our position and see if our position every frame has gotten outside of the acceptable bounds. So to do that, we'll just write a simple check. We'll say if, and an if statement is just going to do something if the thing in the brackets that we're about to put, or the parentheses that we're about to put here, is true. So we'll say something like if, and I'll say transform.position.y is greater than 10. So if the y position is greater than 10, we're going to do the line of code on the next, or the code on the next line. So to do that, the next code will be scene manager. And as I type this, it's just going to be red. So I'm not going to get any IntelliSense. The reason for that is that our scene manager hasn't been added in with our using statements. So if I go up to the top, we're only using Unity Engine, not Unity Engine.scene management. So if I click off of this, or move my cursor, and I hit Alt-Enter, I'll get an option to add a using Unity Engine.scene management statement up to the top. So I can just click on this and it's going to add it right in, and Scene Manager is going to turn light blue. Suddenly it's accessible and I can use it. So now if I hit dot, I'm going to get some options here. There's a get active scene, a get scene at, get scene by name, get scene by path. We're just going to say, well, let's keep looking for it, load scene. We're just going to reload our current scene. So we'll say load scene, and then open parentheses, and load scene wants either a build index number, which is essentially the order that you've added the scenes to the project, and it's not how you've saved them. There's actually a scene management system that we'll use later where you can add scenes in and we can reference them by index, or alternatively we can use the scene name. So what we want to do is just reload the current scene, and we can actually get the current scene with scene manager dot, and look at that, get active scene. So I'm just going to go down, hit enter, and then it's going to want an open close parentheses, and then we'll say dot name. So we're getting the active scene's name, and then we're loading it. In fact, let's split this out and let's change the way our if statement looks a little bit. So I'm going to zoom in just a little bit more here. And with an if statement, we have two options. We can either run the one line of code after it, or we can put the little braces here, and it'll run everything inside the braces. Now, I've added the braces, but my scene manager load scene chunk is no longer inside those braces. So it will actually run every update and not just whenever we do the position check or whenever we pass that position check that our Y is too high. So we're actually going to take this and cut it. So just Control X. And then I'll click right in here on line 17 and Control V to move it. I could have also alternatively just moved the brace so that it encompassed it, but doesn't matter either way. So now we've got this little bit of extra space here. And why did I do this? Well, it's because I want to take this scene manager.getActiveScene name, and I want to cut that as well. So I hit Control X, and then I'm going to go up one line right above 17, and I'll say string current scene name equals, and then I'll paste. So we're going to get the current scene name into this string, and then I'll copy that with Control C. So double click to select it, Control C to copy it. Then I'll click right here and Control V to paste. So we're going to get the scene name into this string variable, and then we're going to say, hey, load that scene. It works either way. I just wanted to make it a little bit more explicit and write it more how I would write it in the real world so that it's very easy to tell what's going on and it's easier to read and go through. So I'm going to get rid of this extra line here on line 20 with Shift Delete and save this off, and then we'll go play it and see if our transform position.y value, so our y position, gets greater than 10, we should see our level just reload. Let's try it out. So we'll hit play and then grab the bird and launch him, and he's not going very high. Let's select the bird real quick and look at his y position. In fact, if I drag him all the way up to the top, I still can't get him up to above 10. So I need to force him up above 10, and I'm going to take my game view and my scene view side by side, just click on him and drag him and watch his Y value go up, and when it hits 10, you should see the entire scene just reloads. Yep, there we go. Everything just reloaded. So let's change it real quick so that we can launch him that high. And if you remember, when we drag him down and release, he's going in the direction towards our start position times some multiplier. And right now I set that multiplier to 100. You may have cranked yours up already, but if not, let's go in there and turn that value up. So scroll down here to this multiplying part on our AddForce, and let's change this from 100 to like, oh, I'm going to go with 600. So we're going to add a lot more force, 6 times the force that we were with 100. We'll hit play again. We'll launch him up, and I'm going to select the bird. I'm going to click and drag and launch him, and he goes flying, and look at that, it reset this time. So let's do it one more time. Click, drag, and he goes flying, and it resets. Notice that I'm losing the selection of the bird, and that's because the whole level is getting reloaded, and the bird that was there, that instance of it, doesn't exist anymore. It's a new version of the bird. So we don't have it selected in the inspector anymore. But now I think you can see that we're actually able to launch. You also might notice that launch value is really, really high. So let's talk about how we can turn that down and make it adjustable, and then we'll go in and fix all of the other cases where our bird could get out of range or sit down too long. So we'll go back to our bird script, and what we want to do is change this 600 value into a variable, something that we can modify easily without changing code constantly. So we can change this up while we're running and while we're playing, just doing it live, and not have to worry about recompiling or going back and forth to code. So to do that, we're going to introduce a new variable here in replacement of this 600. And since it's going to be a private field, we're going to use that same underscore casing, or the underscore convention. So I'm going to select the 600 and I'm going to say underscore, and I'll say launch power, just like that. Now I'm going to hit escape, and it doesn't exist yet, so I'm going to actually hit Alt Enter and allow it to generate a field, which is the first option. Again, we can go up and type these things, but I really prefer to just keep it simple and use the auto generator as much as possible. Plus, I want to show how the auto generator is going to get it wrong here. So I'm going to hit Enter, and it created a field, but it didn't go to it, so I can't see the field. I could scroll around and look for it, kind of go up. Look, I can see it up here. But I also wanted to show you that you can also hit F12 with the mouse cursor on it, or with the caret on it. I can hit F12 and it'll go right to my launch power variable. Now there are a couple things wrong with this. One, I don't want it to be a vector2. I don't want to change the power upward versus the power to the right. I want it to just be a single value. With a vector2 here, if I put 2 for the x and 1 for the y, it's going to go twice as fast to the right and only whatever the normal speed is up. And I really don't want any of those. I want numbers more like 600 or 500 or something. So I'm going to change this, instead of being a vector2, to being a float. And the way this is going to work, if I scroll down here, because we're multiplying a vector2 times a float, it's actually just going to multiply the x value and the y value times this single value. A float is just a floating point number. It can be anywhere from a very, very small negative number, or a very, I guess, big negative number, to a very big positive number with a lot of decimal points in there. So you can have 1.00003, or we could have 3 million in there. We can have a big variety of numbers, and a float is usually what we use for most values in game development. Sometimes we use other things for different scenarios, but a float is kind of the default. So we've added this private float here. And remember, I said that we could add the private accessor there and it would be exactly the same. And that's actually the way that I like to do it. And it's mostly just so that they line up and that they're easier to read. And it's very obvious that this is just a private field. So we've got the private keyword there on both of them now. Again, you don't need it. You could remove it if you want, but I would recommend keeping it. And then we need to give it a value. So our initial position gets a value in awake. Another thing we can do with variables is give them a value when they're created or defined. So we've got this launch power, and I'm going to give it a value of 500. And then what I'm also going to do, though, is go to the beginning of this line, and I'm going to add a square brace, which is the key right next to P. And then I'm going to type in serialize field with capital S and a capital F, and then add a closing brace, that square brace right there, and then a space. In fact, I'm actually going to add another line here so that this is on a totally separate line. This serialized field attribute is going to do something special. So go ahead and hit save. Remember, File, Save, or Control S. And then we'll go back into Unity, and let's take a look at our bird again. You're going to notice something different about him. If you look at the bird script, we now have a launch power variable that we can modify. So now I can adjust this launch power. I can click and just drag left and right, or I can go in and type in a number like 350, and I can just adjust this value in the inspector without needing to go back and change the code. The 500 that I typed into the code will be the default, so if I add a new bird, it's going to just default to 500, but I can change the value to whatever I want. So I'm at 350 now, and I can launch him and see that, hey, that's pretty good. It might be a little bit too strong, though, so I'm going to stop and maybe turn it down to 250, hit play again, and relaunch him, and oh, there we go. I've got decent power, and I think that's probably an okay value. And of course, you can adjust this and tweak it as we go along and just keep changing it. You can also make just about any variable public like this, or not really public, but serialized so that it shows up in the inspector and can be modified. Now, most of the time we do this for things that are going to be modified by the game designers, not so much the programmers. Programmers tend to like to hard code the values or set in the values that are going to make sense and not need to customize them later. But when we have design data like this, like how far does this bird launch, we want to make sure that it's customizable by design so they don't need to go into the code and change it to make their adjustments. Also, we might want a variety of different birds that fly at different powers, and we want to be able to customize it on the bird without writing a separate script for each one. Now let's make him reset if he flies too far to the right or too far to the left. To do that, we can go into our if statement here in our update and add in another check. So one way you could do this is to copy this and then paste it and say, hey, if the X position is greater than 0, then do this. Then we could paste it and say, hey, if the X position is maybe less than -10, so we've gone 10 to the left, then do the same thing, reload the current scene. And we could say, hey, let's paste it one more time. I'll paste it right up here. If the Y value is less than, and let's say -10. So say we went anywhere too far to the right or too far to the left. Let's do a reset. This is actually going to work. Let's go try it. And then let's talk about how we can fix that, because it's a little bit ugly and we've got a lot of code in there doing the same thing. So I've got it there and I drag him over this way and he goes flying to the left and it resets. I grab him here, it goes flying to the right. Oh, did he even do it? Go flying to the right. And eventually he gets far enough over, he resets. And I think if I can get him to just drop down below, let's see. Is it possible to get him to launch so that he just drops down off the edge? No, he still always resets. Well, if I take him and I just drag him really low down below -10, we can see everything resets again. So it all works, but how can we clean this up and make it so that our code is a little bit easier to understand and not a copy-paste mess here? We have a couple options. First, I'm going to delete all of these duplicated transform.position checks in all of this code. So I'm going to go right here, select it all, and hit delete. So that's just shift at the beginning, click to the end, and hit delete. Get our update back to looking just like this. Remember, it's shift delete to delete a complete line like I just did. So another option we have is we can add in an OR statement to our if. So we can say if the position's Y value is greater than 10, and then I can do space, and I can do double pipes. So this is shift and the key right above enter on most keyboards. It's the one where your backslash is. So if you have a weird keyboard and your key's in the wrong spot, I'm sorry, you'll have to find it, but it's this little pipe. So you hit it twice. So we'll say if the position.y is greater than 10, and then this is or, this little chunk of code means or. And then what I usually do is put these on the next line. So I just say enter, transform.position y is less than -10. Then we can say again or, so double pipes, transform.position.x is greater than 10. Then double pipes again, or transform.position.x is less than -10. So now we're checking to see if we've gone outside any of those areas, or if any of those values have gone outside those acceptable ranges. And if so, if any one of those is true, we'll load our scene again. So I'll save, we'll go back in, we'll play one more time, and we should see the same exact behavior, but with a lot less code. So we pull, we drag, he launches, and it resets. We pull, we drag, and launch, and, well, not resetting there. So we need to address that situation, but let's try that launch to the left. Okay, so let's talk about the situation where our bird just sits on the ground. How are we going to address that? Well, we'll go back into that same chunk of code, and we just want to set up another way to reload our scene, right? Or another condition for why we should reload. So to do that, we're actually going to implement a little bit of a timer. What we want to do is say, once we've launched our bird, and our bird has stopped moving, we want to start counting some time. And if that time that he stops moving passes maybe like a second or two, so he's been sitting there kind of not moving at all for 2, maybe even 3 seconds, then we'll do a reload. We'll say, hey, okay, we've obviously not beaten the level, we just kind of landed and crashed, so let's reload the level. So to do that, we're going to need to keep track of a couple things. First, we want to know whether or not we've launched our bird. To know if we've launched our bird, we can actually just look at this gravity scale here. So our gravity scale is 1 when we've launched our bird, and it's 0 before that, right? We could also, though, add in a Boolean parameter or a Boolean field here that says, hey, we have launched our bird. And that's what we're going to do. So we're going to go up to the top here, and right below this initial position, we're going to say private bool, and now bool can just be true or false. It's just a way for checking something like an on or off state, or whether something has happened or not happened. It's just a true or false statement. So we'll say bool, bird was launched, and a semicolon. Now the default for a Boolean value is always false. So our bird was launched will be false at first, and we'll copy this. So I'm just double click and select it and Control C to copy it. And when we do the on mouse up and we do this launching of the bird, right after we set the gravity scale, we'll hit enter. We'll say bird was launched equals true. So now we know that our bird was launched, and our counter or our timer for, hey, have you been sitting down too long, can start counting. Now, how does that work? Well, we'll go up to our update, and after we've done this check to see if we're outside of the position, actually, you know what, before we've done it, before we do the check to see if we're outside the position, we'll add in another little bit of code. So I added 2 lines right here after the first brace of our update. And we'll say if underscore bird was launched. So this will only happen if this is true. And then we're going to use an and statement. So we'll say and, which is kind of like or, but requires both of them to be true, which is just going to be shift 7, give us the double ampersands, and we need the 2 of them. If you only do 1, you're doing something different. So you need the 2 ampersands there. So we'll say if the bird was launched and get component, and then we need to put in the less than sign and do rigid body 2D. I spelled that wrong, RIGID body 2D. And then we'll say open close parentheses, dot velocity. So what we're doing here is we're getting the rigid body velocity, or the rigid body component, and then reading the velocity. The velocity is a vector too. It's going to tell us how fast it's moving to the left and right along the x-axis and how fast it's moving on the y-axis. But it also has a dot magnitude option. This will tell us how fast it's moving combined. So it's just going to take the x and y movement and combine them together and give us the 1 magnitude. So say if the magnitude is less than or equal to 0, should never be less than 0, but we'll just put in the check there. Less than or equal to 0. Or actually, let's do less than or equal to 0.1. So if it's less than 0.1, so we're very slowly moving, maybe we're just kind of like teetering back and forth or slowly sliding along, something like that. If we're at that point where we're going that slow and our bird was launched, then we're going to add another brace here, and we'll say time sitting around. That's just like our timer, so how long it's been sitting there waiting to reset or not doing anything. And we're going to say plus equals, and this is going to increment it by some amount, and we're going to use a special variable here called time with a capital T dot delta time. I'm going to put a semicolon at the end. We'll talk about what this is, and then we'll add this so that it stops being read. So time.delta time is the amount of time since our last frame. Remember I said update gets called once per frame. So if we're running at 1 frame per second, time.delta time is going to be 1 because it's in seconds. If we're running at 2 frames a second, time.delta time is going to be 0.5 or half a second. If we're running at 4 frames a second, it's going to be 0.25. If we're running at 60 frames a second, it's going to be 0.16. And you can figure this out just by dividing 1 by the number that your frame rate is. So if we go like calc, let me pull up my calculator real quick, and we do 1 divided by 60, you see that this is what we should expect for time.delta time, assuming that we're running at 60 frames a second, that exact frame. Now this is going to vary dramatically from frame to frame, just based on the system that you're on. We could be running at 100 frames a second, and it's bouncing between 100 and 110. So don't expect this value to be static or anything. It's meant to be used to, well, really take into account time and use that to smooth things or just account for it in our code. So again, if we run at like 4 frames a second, we do 1 divided by 4, we'd have a 0.25, or otherwise known as 250 milliseconds. In our other case, we're at 16 milliseconds at 60 frames a second. Let's close this out and let's talk about our time sitting around. So our time sitting around doesn't exist, and I'm going to use the same shortcut that I did before. I select it, I'm going to hit Alt Enter, and I'm going to generate a field. And look, if you look here, you can actually see it's going to do a float. So I'm going to hit Enter, and we got a private float time sitting around. Now I'm going to take this and I'm going to move it. So I'm going to select it, Shift at the beginning, and End to select the whole thing, and then Shift or Control X to cut. Go up here and Control V to paste and hit Enter. The only reason for that is that I want to keep my serialized field a little bit separated, only for readability. It doesn't make any technical difference, but I like to keep things as readable as possible because I have to read the code constantly, and if I make it easier for myself, it just makes my whole life a lot easier, I guess, and it makes just building projects easier. So we've got our time sitting around is now incrementing if our bird was launched and our velocity is below 0. So remember, when we first launch, our velocity is going to be some crazy number. Not until we land and just sit there does that timer start counting up. So our time sitting around is going to go up. And then we can just check here in our if statement, we can say if any of those positions is the case, or if time sitting around, let's go select it, is greater than 3. So if we've sat around for more than 3 seconds or we went out of the scene, then hey, go ahead and reload us. So let's save that, and then we'll go back into Unity, and we'll hit play. And I'm going to show you a little trick here where we can actually see what that time sitting around value is. So let's go look at our green bird. And right now we can't see time sitting around because it's not a serialized field. And you might think, hey, I want to see what that is, and maybe I'll make it serialized so that it shows up. That would work, but we don't really want to do it that way just because we don't want to be editing that value in the inspector. So what we can do is choose this little option right up here, and oh, it goes off the screen, so just click, select it, and choose the debug option. The debug option, and this can get confusing, make sure that you remember that you've turned this on, because it's going to make every component look very weird. It's going to show all kinds of extra info about them. But if we look at our bird, you can also see it's going to show that time sitting around. So now if I grab my bird and I drag him and I just kind of launch him, look, the time sitting around starts to count up, and then he resets. If I do that again, let's just drop him on the ground. Oh, I got to go reselect him. Oh, okay, here, let's try that once more. So go select my bird. I go find the bird script. Watch that time sitting around value. Remember, it doesn't do anything until he's been launched and is not moving very fast. Then it starts counting up and then resets. Again, you can turn that back off, and you definitely should turn that back off by clicking here and going back to normal mode. It's really nice for being able to view those private fields, but it also ruins a lot of custom inspector stuff and makes the editor in general much harder to work with. It's only there for actually debugging and looking at things that aren't meant to be public. So there we go, we've turned it back off, and now we should be able to launch our bird off in any direction. He resets, and if he just lands on the ground and sits around, he resets. Now I want to add some fun by giving us something to hit. So let's go back to OpenGameArt and search for a crate. Now I want to point out that some of these crate options aren't actually going to work. Obviously the 3D ones won't work, but also if you click on some of these and you see the SVG extension, those aren't going to work by default either. SVG is a scalable vector format. It doesn't work by default in our game engine. We have to do some extra stuff, and we're going to avoid those for now. Instead, we want to find one that uses a PNG. So I'm going to go through, and I believe this pixel wooden one is a PNG. Yep. So I'm going to grab this file, just click on it and download it. Put it into my downloads folder, and then I'll pull it into my Unity project. So go back into the Unity project, and we'll just take it from right here and drop it in. I'll go select that crate again and make sure that the texture type is on Sprite, and that looks good. So we've got a 256 by 256 sprite of our little crate. Now we want to add our crate into the scene. I'm in the game view right now, not the scene view, so I'll switch to the scene view. Right click and drag to get over to where I want to put it. I think I want to stack up these crates right about here. And I'll take the first crate and just drop it out, and look at that. I have a crate, but I can't see it. The reason for that is my order in layer. Remember, the order and layer matters here, and our background is at 0, so anything that's not above 0 might show at the same level or behind it. So if I drag that up to a 1, I'm good to go. Another option I have, by the way, is going to my full background, and I can just set this to -1. Now if I go back to this crate, and I set the order and layer to 0, or I pull in something new, it's not going to be necessarily behind the background. I'm going to set the crate to 1, though, just in case. Now, our crate is definitely too big, right? Our little bird shouldn't be flying up against these giant crates, so I'm going to scale it down. To do that, I'm going to hit T, which is going to give me this nice little rect tool. It's this one right here. So T is the hotkey, selects this thing right here. And now you can see I can grab it and I can drag in all different ways and resize it. I can even make the scale negative. Look at those values. They're going negative and negative. I don't usually want to go negative, though. Instead, what I want to do is hold Shift while I'm dragging this around and make it so that the values lock together. So our X, Y, and Z are all going to change the same. It's going to keep it at the same aspect ratio. Then I want to get down to about the size that I want. I'm thinking, realistically, I think about 0.5 is good. Once I've got it close, I just go in here and just type in 0.5, tab, 0.5, tab, and then a 1 for the Z, because the Z doesn't matter. Okay, so we've got our box right here, about half the normal size. And then I want to make it so that our box can fall and get knocked over. So remember, there are two important components here. We need the rigid body for falling, and we need the collider for handling, hitting things, and actually landing. Otherwise, it's just going to keep falling forever. So click Add Component, clear out my bird search, and go to Physics 2D and find the Box Collider 2D. And look here, it just made a green outline around the box. If I toggle it on and off, you can see that green outline kind of disappearing. In fact, let's switch to the Move tool now. It makes it a little bit easier. That Rect tool kind of hides the green outline. But hopefully you can see that just going on and off. Got the box collider there. And then let's add a rigid body component. So hit Add Component. This time I'm just going to type RIGI and have it filter down, RIGI, and then choose the 2D option. So now if I save my scene, Control S and hit play, I should see that crate appear, and I should even be able to hit it. So if I pull my bird back and release, look at that, he can knock the crate around. So I'm going to stop playing, and I'm going to do something important here. I'm going to go select my crate, and I'm going to hit F2 and rename it to crate. I said it's important. It's not super important, but I think it's good to just keep things named well. So we've got our crate there, and I want to make another crate. I want to stack these things up so that our bird can fly into them and knock them over. So what do? Do I just take another crate, drop it out, and go through that process again? Of course not. There's a much simpler way to do it. What we'll do is select the crate, right-click on it, and choose Duplicate. Now I have a crate with a little 1 next to it. This is a second crate in the exact same position, so it looks like it's on top of it. On the Move tool again, so that's W, or click up here, I can just click the green arrow and drag it up, and you can see I've got 2 of them. Now I can do the same thing again, just right-click and hit Duplicate, and grab and pull it up. There's also, by the way, a hotkey. So if I select Crate 2 and I hit Control or Command and D for Duplicate, it'll do the same exact thing, and I can drop up another crate. So now I've got 4 crates, all slightly above each other. And remember, these things are just going to fall down and land on top of each other because they have a rigid body, they have a box collider, and they have a gravity scale of 1. So they're just going to follow normal gravity and fall right down. Let's hit play and watch that in action. There we go. The boxes are sitting on top of each other, and if I pull my bird back and launch him, you can see I can just knock them out of the way. Look at how easy that is. Before we build the next feature, I wanted to show you again what it looks like. So let's grab our bird and pull him back. This is in the final version of the project, and notice that little set of arrows. You might already know what they're pointing to. Think about it for just a moment. Remember that start position that we cached? These arrows are actually just pointing directly from our bird to our start position. And as soon as I release, they go away. So let's talk about how that's done and how we can make it happen in our project. First, I'll stop and get that out of the way, and then we'll stop playing in our main project, and let's go take a look at our green bird. I'm going to zoom out my scene view so that he's visible here. By the way, I can also, with my mouse over the scene, hit the F key to focus him, but then I got to zoom back out because it makes him kind of a highlight there. So let's collapse down the rigid body and the sprite renderer and all of the rest of these components because we're going to add in a new component called a line renderer. So if you click the add component button and just start typing LINE, you should see the line renderer option appear. So we'll click on that. And a line renderer is a special tool for drawing exactly what it says, lines. Now these can be straight lines or they can be crooked or curved or whatever we want, but it's essentially just a bunch of straight lines combined together with the different points to make whatever shape that we want. We're just going to do a straight line from one point to another though. We want to go from our bird to that center or starting point. So let's look at how a line renderer works. It has a couple options here. There's a loop checkbox and a tolerance. We don't need to worry about those. There's also this width slider, which you can't see anything yet because there's no line drawing, so we can't see it adjusting. And then there's a color option and a material option, so we can change out the way that our line looks. But first we need to expand out positions. Our positions is actually what's called an array. It's a set of data points or a set of vector 3s. Notice we have X, Y, and Z. And it's set to a size of 2 by default. But also by default, the starting point and the ending point of our line are exactly the same, except for the Z value. So our line renderer is trying to push backwards into the Z, which doesn't work really well in a 2D game. So we're actually going to change the Z to be a 0. And then let's just change this X value and crank it up. So if I click here and just drag it over and set it to like a 20, and you notice that we still don't see anything, but if I zoom out a bit, look at that. You can see this weird purple line sticking out of the right. So there's a couple things going on here. First is that our starting position is right here behind our background. So if I actually go select my background and uncheck it to disable it, we can see the line is going from this 0 point over to 20. But it's not rendering on top of my foreground and it's definitely not in the right place. So first let's fix that rendering in front of the background thing. So if we go select our green bird and we look for the line renderer and scroll down, we have this materials section. Now, material is just a combination of what's called a shader and textures and other textured data or settings data that tell the engine how to render our objects or how to render the different things that our materials are assigned to. By default, it's on this none material, which is that bright purple. You may have seen this in games when things bug out or something's missing, you get this weird bright purple texture. It's so that it's really obvious, hey, something's wrong, go fix it. In our case, that's exactly what's going on. We have this bright purple texture saying, hey, you haven't given me a material yet, you should probably go do that. So if we go to the materials section, and this could be collapsed, by the way, and just expand it out, we want to leave the size at 1 just like it is, because our line renderer only needs this one material. And then we can click the little search button here. This is going to bring us to all of our different materials in the project. There's one right here called Sprites Default. By the way, if you're in the list mode, it's just this little slider to go back and forth. So you can grab it and drag to list mode or this big preview mode. Or you can go right in between. I'll go to list mode now. We'll choose Sprites Default and look at that. Our sprite now, or our line renderer using the sprite material, is now drawing on top of the background. It's now a sprite, so it's drawing kind of in the right way. Before it was doing a 3D version of it, or using the material made for 3D rendering that doesn't work well with our 2D sprite background. So we've changed that, and now we've got the line somewhat in the right, well, at least visible, but it's not in the right position, right? We want the X value to be really kind of like lined up with our bird. So you can like drag it down here, grab the Y and drag it down. Now you can see like it's going to our guy to way over here. Still totally wrong, right? Like we don't need this weird line going off into the middle of nowhere. But first I wanted to grab the width and show you how we can adjust that. So if we grab this little piece right here and just drag it down, you can see we can adjust how wide this line renderer is. You can go all the way up to 1 or all the way down to like a tiny little line. So if you just want to do like a flat little line and you don't want to put a texture in there, you can make it nice and skinny, maybe add a color to it or something. We're going to leave it wide though, because what we're going to do is add a texture to it. We're going to do that after we get it hooked up in code though. So now that we've got our line renderer set up, let's go into the code and actually make it go to the correct positions. So that the ending piece is on our start position and the starting piece is wherever our mouse or our bird is. So when we drag it apart, the line goes from that start to the bird. So we'll do that by going back into our bird script. And in our update method, we're just going to add in another check or another bit of code to update our line renderer. But first we need to get our line renderer. Our line renderer is a component. So we'll say at the beginning of our update, we can say get component line renderer. And we use the open close parentheses, dot positions. So if we look at our, or actually not position, set position. So set position, and then we have an index and a position. So we have two different indexes here. Let's go take a look at that. We have index 0, so that's this first position, and then we have index 1, which is our second position. So we're going to set this position right here to just be our starting position. And then we'll set this one to be our bird's position. So we'll set index 0 to be the starting and index 1 to be the bird's current position. Let's go back to the code. So we'll say index 0, and we said we'll make that the initial position. And put a semicolon. Then I can copy this line. So at the end, I just hold Shift, go home, and then Control C, hit end, enter, Control V. Just copied and pasted my line. But I'm going to set position 1 here instead of 0, and we'll set it to the transform.position. So this is going to make the line go from my bird to that starting point. So let's save that off. We'll go back into Unity, press play, and let's watch our line renderer. So now it goes from our bird to that starting point, just like we wanted. It doesn't quite look right, it doesn't look like arrows, but we've got an idea of the direction that we're facing at least. And it also kind of stays after we launch. So we need to address both of those things. We need to give it a texture so that it looks right. We also need to make it not show up after the bird has launched. So let's stop playing again. And first let's fix the code part where we're making it not show up after we launch. So we'll go right back into our code. And then to do that, we can just say in our mouse down, we'll turn our line renderer on. So say get component line renderer dot enabled equals true. And then we'll do a copy of that line. So again, Shift and home to go right from my cursor to the beginning. Control C. Then we'll go to the end of on mouse up, hit enter 2 times, paste, and we'll set the line renderer enabled to false. So here we're enabling the line renderer when we start to drag, and then we're releasing it when we stop dragging. So we'll save that off, go back into Unity one more time, make sure that that works, and then we'll talk about how to change this line into pretty arrows. So there we go, it works there, and I release, and it goes away. Closer to what we want, but we still need the arrow art. Now, believe it or not, the beautiful arrow that you saw was actually something that I made. And I'm going to show you how to make it or how to grab your own arrows on the internet or pick whatever you like. But I want to show you the real quick process of how I made it. So I'm using an open source free tool. Oh, I don't know if it's open source, but a free tool called GIMP. It's a GNU image something something. It's a Photoshop alternative, essentially. It allows you to draw art and do a lot of the things that Photoshop does. And here you can see my arrow that I've drawn. To do this, all I did was go to File, New, and then I chose a width and a height that I thought would be acceptable. 128 by 64 seemed okay. And then went to Advanced Options. This is the very important part. The fill width area needs to not be background color, but transparency. Then I hit OK. Zoom in with Control and my mouse wheel, and then I find the line tool. By the way, I am terrible with doing this art, so if you struggle with it, don't worry, you're not the only one. Or it's the pencil tool actually. Then turn my size way down to like a 1. Let's see if I can go in there and just type in a 1. And then I click here, hold Shift, oh whoops, undo that. Go to the white color so I can get a nice white line. Then I click, hold Shift. Oh, nope. Undo that. So hold Shift. Click there, hold Shift. There we go. And then click over to, I don't know, about here, right around the middle. And then holding Shift, click again to the middle. And you can see that I came up with a line that's way too narrow. So I'm going to undo that with Control Z. Go back to white, because apparently I switched off of that again. And then turn up the size a little bit more. So go to like a 4 pixel wide one. Click, hold Shift, click, and click. And now I've got a very basic little arrow. So to save it off, I go to File, and then we want to choose Export As. We want to put this into a folder that we can find it in. So I'm going to do it in the downloads folder. And we'll just name this white arrow. And we hit export. And this will show up in my downloads folder once I hit this last export button. It does pop up a lot of dialogues. So I'll go to my downloads folder. All right, it actually went to my documents/downloads folder. I had to repop it open to look, documents/downloads. It's important to know where your files are being saved. So I find my download of my white arrow that I've just drawn, and we're gonna drop this into the project. Now, I want to also point out that while you're going along, you could just search on Google for a transparent arrow and pull that in. But if you do, you need to make sure that it's actually a transparent image. Sometimes when you just right-click on these and do a save image as, it's going to save off a JPEG or something else that's not transparent and doesn't work, and you're going to get weird looking things that, you have a checkered background instead of a transparent background. So whenever you're looking for transparent files, make sure that you also go to Tools, Color, and Transparent if you're searching. That way you can find things with actual transparency, not just things that have the word transparent in the search results. Okay, well, I'm going to go with the arrow that I made though, because I think it's nice and pretty, and I'm going to make it available as a download. Just look below where you're watching this and you should see a way to download this arrow and pull it into your project. So I've got my white arrow, and I want to replace this LineRenderer's material with my white arrow. Right now I have it set to the Sprites default so that I can see it. That's not really what I want. I want to create my own custom material. My own material is going to allow me to customize the way that this arrow shows up, and well, not a whole lot more than that, but theoretically we could do quite a bit more with it in a more advanced scenario. So let's set up our material. To do that, we go to our assets folder and we just right click, choose create, and then look for material. I'm going to call this white arrow. And if you hit enter, don't worry, you can just hit F2 to rename it and go back and change the name. And then we're going to assign the albedo of this shader or this material. To do that, we can click on the little circle here and get a pop-up of all of them, and we can go look for our white arrow. We could also alternatively just drop it in. And this is the texture that shows what our thing looks like. It has all of the color and really the drawing data. The primary data of any material is going to be right here. Now we need to make one other change though. Well, first let's actually assign our material and then we'll make the change. So we'll go select our green bird, and right where we had put the Sprites default before, let's put white arrow. To do that, I'm just going to drag it and drop it in. Again, you can also hit this little search box and have it pop up and go double click it to pick it. But either way works, and I want to show both of those options. But notice that I'm still not seeing my line renderer. If I zoom out, I can kind of see a little bit of what's going on there, but it's not looking right. Now, I need to make one more change to this material. So I go select the white arrow material again, and we're going to change this from standard opaque, and we're going to switch it over to be transparent. Now, when I switch to transparent, notice that it starts to show up. That's closer to what I want, right? I want to be able to see the object here, but I don't necessarily want this transparency showing up. So if I change it to cutout, well, that doesn't quite work either. So what do I want to go with? Well, I want to look for, instead of the standard shader, I'm going to switch over to an unlit shader. So I'll go from standard, click the little pop-up, and then go to unlit, and then here we'll choose transparent. So now look at that, we've got this white little arrow, and the main difference here is that when we're using that standard shader, it's going to take into account lighting of our scene. We don't really have any lighting, so it's just going to be dark. If we use unlit, it's just going to match exactly with the texture color, which is that solid white. So now we have this one white arrow. It's not going all the way out to there though, it's not repeating, so let's fix that too. To make it repeatable, we actually need to change something on the texture here. That's this little version of the white arrow, the one that shows the picture. Let's go to the zoomed in mode or the bigger preview mode so we can see it better. So the material has this kind of weird rounded thing. It's actually because it's showing what the material would look like on a sphere. So if we dropped this on a sphere, this weird arrow, it would look kind of strange and wiggly and distorted. If we look at just the texture though, we can kind of make out the white line there on top of the background that's transparent. So we're going to select this texture, and we want to change a couple of things. First, we need to change the mesh type from tight to full rect, which just means that it's going to use our entire texture and not try to shrink it down or cut it down. And the reason for that is we want to change our wrap mode, which is for repeating or like a wrappable texture. Think of something that just repeats over and over and over, which is exactly what we want ours to do. We want to change this to the repeat mode. So we hit apply after doing that, and suddenly we should see our arrows appearing all the way along. Now the last thing I want to do with this is go select the green bird, and you can see I've already kind of played with the width here. I might have cheated there. So we can just adjust it up and down until it looks right, until it's like a good enough width for you. So I go with like a 0.4, 0.5, something like that. So we've got our arrows visible. And if I select off of it, I can see that they look okay without the selection. And save, and let's just play and watch them in action. See our beautiful arrows doing what they're supposed to do. So we grab the bird, and oh no, our arrows are actually pointing the wrong way. They're working, right? I can drag out, look at that, I can also smack this thing, but I can drag them out and they work and they indicate pretty close, but they're going in the wrong direction. So how would we go about fixing that? I need to think about it for just a moment. Remember, if we look at our bird, we've got the position 0 and position 1. We're going from position 0 to position 1. Let's look at our code again. So if we look at where we're setting our positions, so just kind of scroll through till we find the set positions, we're going from position 0 to position 1. It's not really what we want, is it? We want to go from the transform or the bird's position to the initial position. So we can fix this really, really easily. We'll change this 1 to a 0 and this 0 to a 1. So now we're setting our first position or our starting position to be the bird and our second position to be the starting position or the initial position. Now, it doesn't matter if these are in the right order, like if we set position 0 before position 1, but I like to keep things nice and clean and easier to read, so I'm going to rearrange them. To do that, go to the end, hold Shift, Home, Control X, go up in the line, Enter, up again, and Control V, and then go get rid of that extra line with Shift and Delete. So there we go. Now they're in order. We could have also just moved these two, swapped out the initial position with transform.position, anything to get them in the right order. And again, the order there doesn't matter at all. It's just making it easier to read, because if they're out of order and you have to go look at this, you might get a little bit confused when you're reading it and glossing over it. So let's try that. We should get our arrow facing the right direction and our bird launching off with it. Let's see, here we go. We got the arrows. We pull, we release, and our bird goes flying. Great stuff. Now let's add some monsters that the players can kill. Give them a target to take out their bird rage on, I guess. To do that, we'll go back to OpenGameArt and just search for monster, and there are a bunch of these different little 2D monster options available. I'm going to go with the blue ones this time. Last time I did orange. Once you've found the one that you like, make sure that they're 2D, and we'll download the sprite sheet for them. So just pull this in. And then we'll open up the zip file here and go into the transparent PNGs folder again. And this one actually comes with the animations for getting hit. It's got a special frame for that. And then it's got animations for idle, frame 1 and frame 2. So I'm going to copy these two. Just select them both and hit Control C, or right click and hit copy. Then I'm going to go into my project. And I'm going to hit Show in Explorer to pop up the folder. We'll go into the Assets folder, and I want to drop these in, but notice I already have a frame 1 and a frame 2 in my folder, so I'm going to create a subfolder. To do that, I can just right-click anywhere in my folder here and choose Create or New, but that's actually off screen, so I'll do it way up here. We'll go up here and we'll hit New Folder, and I'm going to call this Monster with a capital M. Notice that in our Unity project, if I click over, we're going to get a monster folder that appears. Oh, it hasn't actually appeared yet. Well, I'll show you how to get it to reappear though. First, let's go into the monster folder and paste. So we've got the frame 1 and frame 2 in here, and I click over to Unity and my folder has not shown up yet. So I'm wondering, hey, what's going on? Well, I'm in play mode. Stop playing and suddenly my monster folder appears. Remember before I mentioned that your Unity project isn't going to update when you're in play mode. As soon as you stop, it'll reappear or it'll start updating again and grabbing the new file changes. So here we go. We've got 2 frames of a little monster in our monster subfolder. And I can click on assets to go back to the root. And you may have already put your bird into a bird subfolder. Feel free to do that. It's always good to keep the project clean. Since we've had it so small though, I didn't want to go around rearranging things just yet. So we'll go to the monster folder again, select frame 1 and hold shift and select frame 2. We're going to go about that same process that we did for animating the bird. We'll take frame 1 with them both selected. Notice they're both blue. And I'll drop it right here. Oh, let's just drop it right here where I want the guy to be actually. It's going to pop up asking me to create an animation. I'll name it monster. And it'll be default as a .anim file. And again, it's going to create my animation here and my animator controller here. So if I select, or my controller is here, sorry, I got the words mixed up. My frame 1 here is the controller that got automatically created, and monster is the animation, the .anim file that I actually named. And if I go up here in my scene, I have frame 1, which is the monster, and he's got a sprite renderer and an animator on him. That animator is just set up to play the monster animation. Now I'm going to rename this animator. I'm going to select it and hit F2 and name it monster. And I'm even going to rename my monster frame 1. I'll say monster frame 1. Let's just call it monster-1. And then we'll name the other one monster-2. That way it's a little bit easier to tell what thing we're talking about. So we've got monster 1 and monster 2. Those are the 2 frames of him. And I'll go to this one here, the object that I've actually placed. That's this guy right here. And we'll rename this to monster. Now, obviously, he's too big. He's way bigger than everything else. I'm going to scale him down to, let's try 0.5 and 0.5 on the X and the Y value. And now he's a little bit big. I think he's still a little too big, so I'll go to 0.4 and a 0.4. I think that looks about right. Put him into position behind that crate, and then we'll add on the standard components. So just like we added for the crate, we're going to add a rigid body and a collider. So we'll go look for a rigid body 2D. Now for the collider, remember, we don't necessarily want to add a box collider. Box collider might actually work really well for this guy, but we can also add a polygon collider. So if you went with a non-boxy character, a polygon collider is probably going to look quite a bit better. Now for some reason, my polygon collider is just not showing the renderer there. It's still working though. I can hit play and I notice that he's not falling through, but something's acting a little strange. Let's try adding a box collider 2D. Okay, that one actually is showing up. So I'm not sure why that polygon collider is not rendering. Normally they render fine. I'm actually just going to go with a box collider for this guy though. So I'll remove that polygon collider and just leave the box collider. So I've got this guy here. He's ready to be crushed, I guess. And I'm going to duplicate him. I'm going to select him, Control D, and make one more. So I got 2 of these guys right here standing behind the boxes ready to be smashed. So I'll save this off, hit play. And we'll launch over at these monsters and see if we can take them out. Oh, I was able to knock them over at least. So I didn't kill them yet, but I am able to hit them and knock them over. But also notice what happens. If I pull my bird over here too far, he's going off the screen and I can't really see him. And if I launch over here and I knock some of these guys over to the right, oh, well, that time it didn't happen. But a lot of the time they can just end up kind of off the screen and not really visible. So I want to fix that and make sure that everything on my screen is visible at all times. And we're going to do that with a new system, a new camera control system that actually makes our camera follow our bird around and show these guys all automatically without us writing any new code. The camera system we'll be using is called CineMachine. It comes free with Unity and we can install it through the Unity package manager. To get to the package manager, we go to the window section and then go to package manager right here below asset store. This will pop up a new window and I've already selected CineMachine here, but you can see there are a large selection of different packages available. The reason that these exist is so that Unity can split up the engine into multiple smaller chunks so that when you're building a 2D game, you don't necessarily have to ship off a bunch of 3D functionality and features in your install. It allows you to keep things smaller and just simplifies the entire process. So to set up the CineMachine package, first we need to find it in the package manager. If you don't see it, you may be in the in project filter right here. So right at the top we have all packages selected, but you could be in this view right here where you only see project or packages that are in your project. To change that, just go back to all packages, look for CineMachine, or you can type it up here and search for it. And then once you've found it, select it and hit the install button. This should only take a moment, and it's going to pull in the CineMachine package, which gives us the full camera control system, and it's also going to give us a nice little menu option right up above as soon as it's finished. Now, before we had CineMachine available, we used to have to just write our own custom camera controllers for just about everything. Now I'd say we write custom camera controllers for, I don't know, half the projects that I do, and the other half we just use CineMachine with a couple little settings adjusted because it works so well and it gets the job done and really saves us a lot of time. So now you can see it's finished installing. I can close the package manager window, and I'm going to go to CineMachine, and we have a bunch of different camera options available that we can create. We're going to eventually create the 2D one, but I want to talk briefly about what some of these others are. The virtual camera essentially sets up a camera in our scene that can look in any place and be attached to anything. It's almost like setting up an extra just camera that we can switch to. So we could set up multiple virtual cameras and then tell our camera controller to switch between our different cameras and like show us a different view completely. The free look one is more for a character that's moving around, allows us to turn and look around. The clear shot one allows us to get a clear shot of an object, so we can set up multiple cameras, say, hey, give us the best shot of this character, and it'll do it automatically for us. The dolly one follows along on a dolly. If you've ever seen a dolly in movies, it kind of holds the camera and moves it along and keeps focused on whatever the thing is that it's following. And there are a lot of other options, but let's just go on to creating the 2D camera. So I hit create and suddenly everything broke. All I see is a black screen with my little arrows on it. But if we look at the settings on this VCam, I've selected my VCam that got created. That's the 2D camera that CineMachine made. It's a CineMachine virtual camera. That's what CMVCam1 means. One just means it's the first of them. And then if I select it though and I look at my position, notice that my Z position is reset. It went to 0. Remember our initial camera was at -10, and if we go to our scene view and we're in 2D mode or 3D mode here, we can see that our camera is actually shoved up against the sprites. And if I drag it out here, you can see it's pulling away, and if I go to the game view, it looks correct again. Now let's say I want this VCam to just follow my bird around and just keep my bird centered. Well, to set that up, all I need to do is take my green bird and drag it onto this follow section. To do that, I'll click and hold. I got to make sure that I hold the button down. If I release, it's going to select my bird. So I just hold it and drag over to the follow field, and suddenly my bird is right there in the center. Now if I hit play, we should be able to grab our bird, pull him back, and launch him. You might have also noticed that weird little box. Let's stop and hit play one more time. This little box is showing up because I have my camera selected. When I have this VCam selected, there's actually an option, I believe it's on the main camera here, to show the camera frustum. It's showing the area that the camera is focusing on, and what you can do is kind of set it up so that the camera won't go outside of those ranges. We're not really going to use that though, but I just don't want you to get confused by it. If you have the VCam showing up, you can adjust this and really adjust some of these settings as you drag things around in here. Don't worry too much about that though. It's a bit more advanced virtual camera feature that we don't need to talk about. So we've got our bird here being followed, and let's just go select something else so we lose that outline. Got our bird being followed, but I said I wanted to keep the enemies on screen at the same time as well. So to set that up, we need to actually create a new object. We need to create a tracked object or tracked group, or I guess it's a target group is what it's called in here. So to do that, we could go create a target group camera and it would automatically create us a target group. In fact, I can do that right now. Just go create target group camera, and I can see it made a target group 1 and it made this other VCam. I'm going to delete the second VCam and just reuse the target group. Now I could have alternatively just made a new game object and added a CineMachine target group component to it, because that's all this really is. It's a game object. Just going in here, right clicking and hitting create empty would have made me an empty game object. Then I could go into add component, find CineMachine target group, and add the target group. It gives me the exact same thing. See, if I select them, got the same object. But I wanted to show two ways to do it, and that when you use these menus, a lot of the time it's just creating a game object and automatically adding components for us. So I've got this target group here, and it has a target list, but the list is empty. So I can hit the plus button, and it gives me the option to add a target here. What this is a group of objects that I want my camera to focus on and keep all in the view. So instead of being able to just assign a single thing in that virtual camera to follow, I can assign multiple things. So I'm going to hit the plus button 2 more times so that I have 3 targets available because I have my bird and my 2 monsters that I want to follow. Then I'll take my green bird and drop him into the first target field. I'll take the monster without a 1 behind his name and drop it into the next one. And then the monster with a 1, which is just my second monster, and drop it into this third one. Again, click and drag, don't release until you get over there. Now I'll go to my VCam and I'll assign this target group instead of my bird as the follow. And look at that, we're now focused on the bird and the monsters at the same time. Now if I hit play, when I drag my bird around, and let's go unselect the VCam so I can see things a little bit cleaner, you see that it keeps everybody on screen at once. And I can pull back and release and kill them, and as I get closer, it kind of zooms in and gives us a much better view. Now the last thing I want to talk about with this camera controller is the radius option here. So when we were playing and you go select the target group, try playing with this radius value. And notice that it's going to make us get a bigger area around the target or targets that we've set a radius for. So I set a 2 there and maybe a 5 here. You'll see that it's pushing these guys further to the front. It's trying to keep a radius around them inside of our screen. So you can play with these values and get them to something that you feel looks and acts right. And then we'll start working on the enemy and making it so he can actually die correctly. So for our bird to be able to kill his enemies, we need to give them a script. We need to actually create an enemy script. This will be our second script, so we'll do this right here in our assets folder. We'll right click, hit create, and choose C# script. I'm not going to hit enter yet. I'm just going to type enemy, E-N-E-M-Y with a capital E, and enter. Because I want to make sure that my script name and the class that it gives me match. Now it's going to pop up Visual Studio and go to the wrong file because that happens all the time. But I can just go back in here and double click on enemy and it should open up the enemy file. So now I should have a public class enemy, which is also a mono behavior because this is going to be a component that goes onto our game object. So remember, it needs that :mono behavior or else it can't be a component that goes on there. It's got a start and an update, and we're not going to need either of these. So we're going to cut out all of the code from line 7 to 17. So select it all with the mouse, just drag and hit delete. Now I've got a public class with 2 braces and nothing inside it. Now what we want to do for our enemy is handle what's called a collision. A collision is when 2 objects hit. When our bird hits those boxes, that's a collision. And if we have code in there to listen for these collisions, we can respond to them and do different things. We want to listen to collisions on the birds, or on the enemy, I guess, for hits by the bird, and then make the enemy just poof and disappear and die. So to do that, we can use the next special method that's part of that mono behavior to say on collision, see on CO, and I can already see on collision enter, on collision exit, on collision stay. We want to do on collision enter 2D. You need to, again, make sure that you choose the 2D version. When I was preparing this, I accidentally selected on collision enter without the 2D, got confused, said, hey, why isn't this working? And spent 10 minutes trying to figure it out, only to realize I had left off the 2D because I typed it out. So make sure you use the on collision enter 2D one. Now an on collision enter 2D is actually going to pass us in some collision information. So whenever we get collided with, whenever our enemy hits anything, the ground, a box, another enemy, our bird, we're going to get some info about the collision, and it's going to be in this collision 2D type object named collision. It's a lot of the word collision, right? So what we want to do is check to see if this collision was with a bird. To check that, we can actually read a property on our collision. So we'll say if collision dot collider. Now the collider here is going to be the other object that we collided with. And then we'll say dot get component, and we're going to give it the type of bird, and then open close parentheses, and then we'll say not equal to null. And then add some braces here. And the next thing we'll say is destroy game object and add a semicolon. So what we're doing here is saying, hey, with the other object that we collided with, that collider, try to get a bird component on that object. If there's not a bird object, then it's going to give us a null back. So it's going to say, hey, there's no bird, and we're not going to do this little bit of collision or this little bit of destruction here. If it isn't null though, so it means that we did get a bird back, then destroy our game object. In fact, we could even write this a little bit different. So I'm going to take this little bit of code and hit Control X, and I'm going to add in a property here, or a variable here. So say bool did hit bird equals, and we'll put in the get component is not equal to null. And then we'll say if did hit bird, then destroy our game object. So here we're just kind of representing the same bit of logic in another way that's maybe a little bit more readable. Another way that we could represent this too is to say bird equals collider.getComponent bird. And then this would give us back the actual bird that we crashed into. Then we could say, hey, if the bird is not equal to null, which means that it exists. Null just means that it doesn't exist. It's pointing to nothing. The object just isn't there. We didn't find a bird. So we can say if the bird is not equal to null, then destroy the game object. And this is much closer to how I would actually write my code for this. So save this off. And then we'll go back into Unity. Now in Unity, I'm going to select my monster and add that monster or enemy script to them. In fact, I'm going to select both monsters at the same time. So I've got the first one selected. I'm going to hit Shift and select the second one. And then I'm going to go to Add Component. And I've already collapsed these other components down. So I go to Add Component, type in ENEMY, find my enemy, and add it to both of them. This way I don't have to go in and add them individually. But if I click on them each individually, I should see that I have the enemy script on both of them. Now I'll hit play and see if we can kill those enemies by hitting them with our bird. Now I'm probably going to miss because I'm not very good. Oh, look at that. I killed one enemy. Didn't kill them both, but I took one of them out. Let's see if I pull it over here and just shoot again. Can I knock them both out? Not quite. But I also want these crates to be able to crush these enemies, right? I don't want them to just die if the bird hits them. Kind of like a weird obstacle course. You might want to leave it that way though, but let's say you also want them to die from boxes crushing them on the head. To do that, we'll go back into the enemy script and we can add in another little check here. So we want to say, hey, if the collision wasn't with a bird, but maybe it was with a box or not an enemy, then, and it will hit us from the top, then let's die too. So how would we do that? Well, first we'll check to see if it was an enemy. So we can say enemy equals collision.collider.getComponent of type enemy. By the way, when we put these in these little brackets here, or the less than and greater than, and when you spell it right, these are actually generics is the term for it. We're actually trying to get a component of a very specific type, and we're just giving it the type at compile time so that it's just a clean way of writing, hey, give me this component of this type. And you're going to see this a lot when we have lists or collections of things, or we want to pass around and be specific with types of objects. A lot of the time they'll be in these less than and greater than sections. Okay, so we're getting the enemy, and we'll say if enemy is not equal to null, then return. And what this means is exit out of this method, don't do anything else. Just be gone, you're done, we don't care, we don't want to do anything else with this. We hit an enemy, we're done with stuff. We don't want to continue on. So if we hit an enemy, we're just not going to do anything, we're going to bail out. In fact, we could even maybe have this up above our bird check. I don't think it matters either way though, because we're never going to hit a bird that's also an enemy. Okay, so we've decided, hey, we got to this point to line 21, it means that we didn't hit a bird, and we didn't hit an enemy. If we hit a bird or we hit an enemy, we're going away. In fact, what we should do here is after we destroy, we should return as well so that we exit out. So if we do hit a bird, we don't keep checking for other things. We don't want to destroy our object and then go looking to see, hey, did we hit an enemy? Did we hit a box? Do all this other stuff. We're already dead. Just get destroyed and be done with it. So what do we want to do next? Well, now we want to check to see if we got hit on the top. So if anything that wasn't an enemy or a bird crushed us on the top, how would we deal with that? We can say collider or collision dot, and now here's where we get into some interesting stuff. The contacts section is actually an array of different contacts. It's essentially a collection of contacts. So imagine my finger hits my hand here. I've got one contact. It's where my finger hits my palm right there. But if I happened to hit with two things at the same time, I could end up with two contacts. Like two contacts both hit at the exact time. 99% of the time, we're only having one contact. And in our case now, we only want to deal with one contact. So we'll access the contacts, but we're going to use an array indexer, which is these square brackets, and we're going to put in a 0 to just say that we only want to reference the first contact in here. And since they're 0-based indexes, meaning the first one is number 0, we want to access it at number 0. If we try to do number 1 and there isn't a 1 there, we're going to get an error. It's going to blow up, and we really don't care about that. We just care about the single first contact. That's really all we're going to have 99% of the time. Then we can say dot, and then we want to use the normal. So the normal, I don't want to dive too deep into this, but it's essentially giving us the angle that we hit from. And this is going to give us an X and a Y value. So it's going to tell us if it was to the left, the right, and it's going to give us essentially an X and a Y value on a plot for the direction that the impact came in at. So if we came in from the top, just straight above, we're going to have, I believe it's a -1 for the Y. If we were like straight on the top, if we're at an angle, we could end up with like a 0.7 or something, and then our X value is going to go up. We really just care about the Y value. So we're going to say if the Y value is less than, and I'll say -0.5. So we want to check if that Y came in at anything that's kind of less than, hopefully my weird tilty fingers make sense, but if it's less than 0.5, so it's mostly on top. In fact, we could even say if it's less than 0 or less than a different angle, less than that, but we're going to go with 0.5. So if it's less than that, then we want to do something. But look, I didn't write an if statement. I put a less than and a negative, and that's it. So let's wrap this in an if statement. So go to the beginning. I'm going to go left one space here, add a space, say if, and then open parentheses, and then go to the end with the end key and close the parentheses. So if we hit from the top with something else, and do the open brackets again, and we'll say destroy game object. There we go. So now if we get hit from the top by something else, we should also die, or our enemy should die at least. So save that off and go in, and let's go knock some crates onto these guys and see what happens. Look at that. They both poofed and died. But even though they both died, I didn't get any cool puff of smoke or clouds. So let's put that in now, and we're going to talk about particle systems. To get started though, we need to grab a little piece of art. I'm going to use the cloud from OpenGameArt. So again, just searched for the word cloud on OpenGameArt and found this little cute clouds package. I'm going to open it up. It's a cute cloud game ornament.zip, so I'll download it. Open it up, and then let's look at these two clouds. I want one of them. I think it's that first cloud. So the first one looks like that. The second one is kind of flat. That doesn't make a lot of sense for what I'm thinking, so we'll go with this first one. So I'm going to copy cloud 1, just right click, copy, and then we'll go to our project folder again, and we'll paste this thing in. So go back to project, right click, show in Explorer or Finder again, and go into assets, and then right click, and we will paste to drop this in from that zip file. Remember, if we're playing, it's not going to show up automatically, but once we're done playing, we should see our cloud appear. Okay, so let's talk about particle systems. To create a particle system, we can actually right click and choose Effects, Particle System to just create a new one right in the hierarchy. So again, that's right over here in this hierarchy area, and you might see a bunch of little white dots flying around. I'm going to go to the scene view and take a look at how this views. So we'll go to 2D mode, and let's move this particle system away from the background. So I'm going to hit W with the particle system selected, zooming out with the mouse wheel, and I'm just going to move it up here. Then I'll hit F to focus and zoom in with the mouse a bit. So here you'll see I've got a bunch of weird little dots flying up. That's not what we want at all, right? For our cloud, we want these little clouds, and we want it kind of poofing out in all different directions. So we need to change a couple different things here. First, we need to change the renderer's material. This is the visual thing that we're showing. Right now, it's this default particle system. That's why we see this weird little dot. So what we need to do is create a new material that we can assign for our particle that uses our cloud as the sprite. So to create a new material, we do the same thing we've done before. Right click, choose create, and pick material. We'll call this cloud. So it's right here. I've got it selected. I'll just type in the word cloud. And then we'll assign the cloud to it. We'll switch it over to be a particle system and just have it be standard unlit. So it's going to be an unlit particle material. Next, we'll go into our particle system again. So we'll reselect the particle system, scroll down, and we'll assign this material. See the material section right here? This is where we're going to assign our new cloud material so that we can see our clouds instead of these little dots. So I'll take it and we'll drop it right up there. Now suddenly I see my little clouds. But they don't look right yet. We're still missing something. We still have that gray outline around them. We're not getting the transparency that we expect. Now we need to modify the material, and we can actually expand it out right here below the renderer, or we can go select the material just by clicking on it. But what we need to change is this rendering mode. Right now it's set to opaque, which just means no transparency. Draw it and cover everything with our colors. We want to actually change this to be a cutout, because our particle or our cloud image is just a cutout of a cloud with transparency around the edges. So now it's looking, I'd say, a little bit closer, but not perfect yet, because we don't want our thing just shooting off particles like that. We want particles kind of flying off in different directions, and we really just want them to fly off in a big poof. We don't want a non-stop like shot of particles or clouds coming out of our guys as they get hit. So we're going to make a change to the emission section here. If you expand this out, you see that it has a rate over time and a rate over distance, and then a burst section. If you crank up this rate over time, let's say we set it to 100, you'll see that we're getting a lot more particles. If we set it down to 1, you'll see that we're getting 1 particle a second. So this is just how many particles you want it to create per second. Now what we want to do here is actually set this to 0, because we just want to do a burst. So to do a burst, we just add to the burst list and then leave it. I think 30 is probably a decent value. So you're going to watch, it's just going to do a big burst of particles. But they're not going in the right direction, are they? So to control the direction, we expand out the shape section. And look right here, it's set to a cone, and you can actually see that they're flying out in that cone direction. Exactly what we should expect here. So we set a cone, and if we adjust the angle, we can make them fly out wider. Or we could pull it in and make it much tighter so they go up in almost a straight line. Instead of a cone though, we're going to use something different. We're going to use a sphere. So if we choose sphere and watch it, look at that. Now our particles kind of fly out in a closer direction to what we're expecting. So let's zoom out a little bit and see how far they're going. They look like they go really, really far. And just imagine we've got them right on top of our little blue guy. In fact, let's move them down so they're on top of our little blue guy. That's probably more than we want. We want a much faster, shorter life cycle of these particles. We want them to kind of poof up and then fade away. So we can adjust the lifetime of them by scrolling up here to the start lifetime section. We can turn this down to maybe like 1.5 and watch again. We should just get nice quick little particles. They disappear much faster. But I want them to fade away too. So how do we make them fade? Well, we can go through, let's see, scroll down here. And we can look at size over lifetime. So if we check this size over lifetime, we can actually make them, look, they start to grow. So watch it one more time. So now they're growing over lifetime, but instead what we're going to do is click on this button and edit the curve here. So instead of them going from 0 to full size, we're going to make them start at full size and then go down to 0. So we'll take the red, if I can grab it and drag it. We'll pull it down here, and we'll grab this little piece right here and kind of straighten this curve out. So they're going to start off large and then just kind of shrink down. So there we go. We've got, I think, a much better particle system. Now there are also options for rotation. If you want to make them spin, go ahead and play with those. If you want to make them change color, go ahead and play with those. There are a lot of different options here and a lot that you can do with particle systems, and they're a lot of fun to play with. You can also grab particle systems on the asset store. So if you've looked at the asset store tab before, you may have noticed that there are a ton of particle system options on here. If you decide to use one of the particle systems that are on here, I don't know if I should pull them up. But if you do, just note that a lot of the time the particle system prefabs that you'll get, the objects that have the particle system set up, will have scripts on them. And those scripts might do something that you're not expecting. So if you're seeing weird behavior, take a look and see if there are scripts there. Try removing them or disabling them and see if that helps. Okay, so we've got our particle system set up. And now we need to do something really cool. We're going to turn this into what's called a prefab. We're going to make our cloud poof particle system something that we can spawn at any time whenever one of our bad guys dies. To do that, we're actually going to follow a really simple process. First, we're going to rename this. Instead of particle system, I'm going to call this cloud particles. That's just F2 to rename. And then we take our cloud particles object and we're going to drop it down into this gray area of our project view. So we take it and drop it in, and now it's called a prefab. We'll look here at the extension. It changed to cloudparticles.prefab, and our icon changed here. The color changed. We even got this weird little button to go into prefab edit mode. So what this is a reusable object that our other objects can reference and create their own copies of. So the way that we're going to use this is in our enemy script. So let's go select our monster, double click on our enemy script, and open it up. Now when we destroy our character, we're just destroying the game object, but we want to do one other thing now. We want to spawn a poofing cloud particle system. So to do that, we need to get a reference to our poofing cloud particle system and then call a special method called instantiate. So I'm going to zoom out just a little bit here, and we're going to get rid of these two extra using statements that we don't need at the top. And then we'll add something in right after line 4. So inside of our class, before our onCollision enter, I'm going to add 2 lines, and then I'm going to go with a square brace and add the serialized field attribute. And remember, it closes with another square brace, then a space. And I'm going to say private, and this is going to be a game object. And we're going to give it a name of underscore cloud particle prefab. Nice long name that is really explaining what this is. So we're going to have a reference to our cloud particle prefab that's just referencing the game object or the actual prefab object there. And it's going to be a serialized field so we can set this in the inspector or in the editor. Then what we're going to do is use this cloud particle prefab to spawn a cloud. So we'll do that right before we destroy our game object. Right here we'll say instantiate, if I can spell it right, and then we need to give it an object of the original, which really just means a game object of the original most of the time. So say underscore cloud particle prefab, and I just typed a C and let it autocomplete, and I'm just going to click on it. So we've given it the cloud particle prefab. We say, hey, we want to spawn this, and we could just end it right there. But this isn't going to spawn our cloud particle prefab where we want it. It's just going to spawn it at whatever its default position is. So we need to make a little bit of a change here, and we need to use what's called an overload in the instantiate. So if I go back to the end of the B here and add a comma, and then hit the up and down arrows, you can see there are actually a bunch of different ways that I can use this method. I can give it another optional parameter called the parent. That's the second option. Notice the 2 out of 10. I can give it a parent and an option for instantiate and world space. We don't need to know what that does right now. We will really want to look at this option here, number 4, where we can give it a position and a rotation. And what we'll do is just give it our own position. So give it transform.position. So we're saying, hey, spawn this cloud wherever this enemy is. And then for the rotation, we'll use a special rotation called quaternion.identity, which is essentially like a default rotation. We can just pass that in. So this will spawn us our cloud at our position in the default rotation. I'm going to select this whole line. So go to the end, hold shift, hit home, control C to copy. And then right before the destroy on line 25, now I'm going to hit enter and add in one more line by pasting that in. So now no matter how we die, we'll spawn this cloud particle prefab. Now let's go back into Unity and deal with the one last thing that we're missing here. In fact, we should see it. Ah, there it is, just appeared. Our cloud particle prefab isn't actually assigned. So I'm going to select my monster and drag the cloud particle prefab right into this section. But I need to do that for both of my monsters. So I'm going to select the other monster and repeat that process. Now I'll save my scene, hit play, we'll kill a monster and see if we get a nice pretty poof. Oh, look at that. We actually got a poof right from the start. Let's stop and take a look at why that happened. We have this particle system right here, this cloud particle that we were playing with and working with, and it's already in our scene. So as soon as we spawned or started, it just started playing itself. And it's set to loop. So we don't want that. We just want to destroy it. So I just clicked on it and hit delete and save, and then we'll play one more time. All right, we'll pull the bird back, launch him over, crush one of these guys. There it goes, poofs and poofs. Look at that. So both of our guys died and both of them played their poofing effect. Whoops, and that time none of them died. Let's see. I'm not very good at this, but I think you get the idea, right? We're able to kill them and we get the particle to play on them. Now, what would happen if the particle wasn't assigned? Let's take a look at that real quick. So let's say I go to my monster and I forgot to assign this cloud particle. So I'm going to select it, the little dot here, and just choose none. And then let's hit play and see what happens, because this happens a lot. So I go back and I kill him, and oh, that was the right one. That was the one that had the particle. So let's kill the other one. And he didn't die, and look down here. I've got an error message, a red line there. And if I go to the console tab, you see it says unassigned reference exception. The variable cloud particle prefab of enemy has not been assigned. You probably need to assign it on the enemy script in the inspector. So if I double click on it, well, it's actually not going to open up the error, but if I click right here, it should open up the error, the line where it blew up in code. Let's go back and look at that one more time. So here it says enemy:12. It means that it's in the enemy script on line 12. So it's saying, hey, it blew up here because this thing wasn't assigned. If we read that message, we can tell kind of what it is, saying that that cloud particle prefab wasn't assigned. So it just means that we need to stop, go find it, and go to our project view and reassign it. Now also, if we've got it already assigned here and we duplicate this guy, remember it's Controller Command D, and move him up here, maybe we put him up there, he's going to have the cloud particle assigned. We don't have to worry about it. We're not going to have to reassign it. But if we had copied one before we did that, then our new version wouldn't necessarily have it. Also, he's not in our target group, so the camera's not necessarily keeping him visible all the time. So we'd have to add him to that if we wanted to keep him on there. So far, we've only built one level, and this wouldn't be much of a game if we only had one level. So now we're going to talk about how to make multiple levels, how to transition between these levels, and save them all off. So you can build up a game with as many levels as you want in all different designs and patterns, and move guys around, add in your own enemies, whatever you want to do afterwards. So to get started, we need to create another script. We're going to right-click in the project view, hit create, choose C# script again, and again we're going to type out a name with what's called Pascal casing. So we'll start with an uppercase L. It's going to be a level, and then an uppercase C controller. Let's see if I spelled that right. There we go, LevelController. So this is going to be something that controls what level we're on. Of course, it opened up to Visual Studio, didn't go to my file, so I'm going to go back into Unity, double click on it one more time, and have it pull up our file. Now we're going to get rid of the start method because we don't need it, but we are going to use the update, so I'm going to leave it hanging around. So I'm going to delete start, and what we're going to do here is type onEnable, and this is a method that gets called whenever this game object is enabled. So as soon as we turn on our level controller, it'll run. If we turned it off and turned it on again, it would run again. And what we want to do now is save off all of the enemies in our scene. The goal here is we're going to find all of the enemies available, and once they're all dead, we'll say, hey, we finished, it's time to go on to the next level. So we're going to do that by saving our enemies into a special variable or an array of enemies, which is the type of variable that we're going to use. We're going to say underscore enemies space equals, and now we're going to use another special method that's part of this mono behavior. Let's zoom in just a little bit, and it's called find objects of type. Now it's very important that you get the S here and you go with the plural one. There's a singular one that's just find object of type, and we want to use the find objects of type, which is going to find all of them. If we use the singular version, it's just going to return back the first enemy, and it's not going to be this collection of enemies that we want. So now we need to give it the type, which is that less than and greater than, where we put our type inside it, and that's going to be the enemy. And then we go to the end. I just hit the end key to get there and do an open close parentheses and a semicolon. Now I'm going to hit the home key to go back to enemies, and I'm going to hit Alt and Enter. and it's going to pop up this little option to generate a field, and I'll just hit enter. So what that did was it created this array variable, or this array field inside my class right here on line 7 of enemies. This little bracket means that it's an array. It means that we have more than one. We can use them all. We could go through each one of them and look at data about them. And that's what we're going to do. Again, the underscore is just a naming convention to say that, hey, this is part of my class. It's not a parameter that got passed in or something that's part of just a method. It's actually a field on my class. And again, it's a naming convention. It's not a hard rule, but it's something I would recommend you follow. Now we need to deal with how to check if they're all dead. So that's going to happen in our update. So to know if our enemies are all dead, we can just say for each, and this is going to loop through all of our enemies. I'm going to say for each enemy, there we go, spell it right, enemy. So it's the type enemy and the variable enemy in underscore enemies. And then we'll add some braces around here. So what this is doing is it's going to loop over or go through each enemy, and it's going to put them into this variable here and then run this code. So we can say, hey, I want to do something for each of these enemies. I want to run a bit of code. So I can say for each enemy in enemies, and I'll get this first enemy the first time through, and then it'll run the second enemy through, or run the third enemy through, and so on. So what we'll do is say if enemy is not equal to null, return. So what we're doing here is saying, hey, if this enemy in our enemies list is not dead yet, because once our enemy dies in this enemy script, it gets destroyed, and the enemy is going to be changed to null. It'll no longer exist. It'll be destroyed in our scene. So if the enemy is not equal to null, we still have an enemy alive. We don't want to finish or go to the next level because we haven't completed it yet. So we'll go through each enemy. If any one of them are alive, we'll just return and exit out of this update method. So why do we do that? Well, because if we don't kill all of them, or I mean, if we do kill all of them and none of them are not null, we're going to get to this line 23. And here, let's start by just writing out a log entry. And we haven't talked about log entries. A lot of the time people go straight to them, but I think that they're relatively boring. But here, I think it's worth just pointing out that we can do it. So we'll say debug.log, casing matters again, and then we'll do open parentheses, and then we put our log message in quotes. And I'll say, you killed all enemies. And you need to make sure that you're using the correct quotes. It's just the quotes right next to the enter key, the one next to this little single quote. Don't use the single quote, use the double quote. And then we'll close it off with a semicolon. So now if we've killed all the enemies, we should just say in the log every frame, hey, you killed all the enemies. Let's go try that. In fact, let's what I'm going to do here to make this even easier on myself, I'm going to go select all of my crates. I'm going to uncheck them. So now all of my enemies should just fall to the ground, and I should be able to slide right into them. And then let's go to the console. This is where we'll see our log. And make sure that you have this little button on. This is the info button. This is the warning button, and that's the errors one. I'm going to turn them all on. Okay, we pull it back, we shoot, and I didn't kill them all. Okay, let's try making this even easier. I'm going to disable all of the monsters but one. In fact, I'm going to delete them. Well, yeah, I'm going to delete them right out of here. I'm just going to leave in the one monster. And I'll hit play. And we'll go fly over there and kill him. And, well, we didn't see our log entry, did we? So why didn't we see our log entry? Let's talk about that for a moment, because this happens all the time. So we created a new script. We created our level controller. Let's zoom this out a little bit. And in fact, let's get rid of these extra using statements up here. But we're not actually putting this in our game yet. We haven't put a level controller in our game. We made a script for it, but there's no game object for it. So we need to go in here and hit game object, create empty, and then add a level controller component. So type in LEVE, and it should auto-complete. I'm going to reset the transform just because I like having all of my game objects that aren't really a thing representing an object in world space to be at the default position here, just so that it's really clear that this is just a special object that's running this script. Now I'm also going to name my game object level controller because I want to be able to find my level controller easily. I want to be able to look over here and say, hey, there's my level controller. All right, let's hit play one more time. Go kill this bad guy again. And look at that, you killed all the enemies, just spamming along in there. Okay, so we killed all the enemies. That's good, but what if we want to go to our actual next level? Well, to do that, first we need to make a couple little levels. Let's go re-enable these crates. Hopefully you didn't just remove all your crates. And then I'm going to go to my project view and look at our scenes subfolder. So our scenes subfolder just has this sample scene. I'm going to switch to list mode just by dragging this down. We just have our sample scene right now. Let's do this. File, save as, and let's go to the scenes folder, and let's call this level 1 with no spaces. Keep it nice and simple, level 1, no spaces in it. Then let's add a couple more crates here. So let's just select a new crate. I'll duplicate this one. I'll put it up here. Maybe duplicate that one, put it right there. Duplicate that one, drag it over, and drag this over. Get these in kind of a weird position. And maybe I'll take this monster here, duplicate him, and put another one up top. And remember, it's Control or Command D to duplicate, or you can right click in here. Then I'll go to my target group, and I'll make it look at my two monsters. Oh, I've got one monster there, got the other monster there. And then I'll do File, Save As, and we'll call this Level 2. But we're going to put it in that Scenes folder again, Level 2. Okay, so now we've got two levels, and we want to be able to go from level 1 to level 2. Let's go open level 1 by double-clicking on it here, and we can also open level 2 just by double-clicking, so we can go back and forth. I'm going to go into level 1, though, and we're going to do one more little thing to make it so that our levels can actually load. Actually, first, let's see the problem. So let's go into our code, and what we want to do now is say, hey, when we finish this level, you've gotten to this point, load the next level. So say, here we want to load our next level. To get the next level, or to load it, what we'll do is say string next level name equals, and then we'll put quotation marks, and it's going to be level because we're naming our levels level 1, 2, 3, 4, 5, whatever. And then we'll say plus, and then here's where we need a special variable to keep track of the next level name or the next level ID. So I'll say underscore next level index. I think that's a good name for it. Now, next level index doesn't exist yet. That's why it's got this little red underline here. So I'm going to go right above my enemies, right after line 4. I'll add a new line, and I'm going to say private static int, which is an integer. This just means it's a number between negative, I forget, some giant number, 2.5 million or something, or billion, and positive that number. So this is just a whole number with no decimal points. And we'll call this next level index. So now we've got an integer and this static keyword. The static keyword means that for every level controller that we have, they're all going to reference this same variable. So if we had a different level controller on every scene, which we do, the enemies for it is going to be different. It's going to have its own list of enemies that it fills on its own on enable. But they're all going to share this next level index. So if I change the next level index on a level controller in one level, it's going to change for the next level index for every other level controller. It's essentially always referencing the same number. It's not its own number per controller. And that's really what the static keyword means. Okay, so we've got this next level index, and we want to set it to 1 because we're going to increment it and then load the next level. So let's set it to 1 because we're loading level 1 at first. And then when we finished it, we want to increment that level index, get our level name, and then load that level name. So to increment our level index, we'll actually add one line right here above line 24. And we'll say next level index plus plus. So what's going to happen here is next level index will start off at 1. Once we've killed all of the enemies and it gets past this part of code, next level index will increase by 1. Plus plus just means add 1 to a number. So it's going to go up to 2. And then our next level name will be level 2. And it's going to combine this into a single string or single bit of text that says level 2. The final thing we need to do is call scene manager. And remember, it doesn't autocomplete because we don't have using Unity Engine.scene management in here. But if I hit Alt-Enter, let's see, try it again. I usually can get this using Unity Engine.scene management option to pop up and click on it. If you don't get it to pop up, you have a problem with it, just type it out using Unity Engine.scene management with a semicolon right here on line 2. So say scene manager.load scene. And again, open parentheses, and then we'll just give it next level name. We add the semicolon and save, and we are almost done. So go hit play, we'll watch the one error, and I'll show you how to fix it. And then we'll be able to load into our level. So we play. I'm gonna go to this console window again so I can see my errors appear. Pull back, and let's see if I can kill this guy. I might take a couple of tries. All right, come on, little blue guy. There we go, he's dead. And look at this, we've got errors. It says, you killed all enemies. Scene level 2 couldn't be loaded because it has not been added to the build settings, or the asset bundle has not been loaded. To add a scene to the build settings, use File, Build Settings. You killed all enemies. Level 3 couldn't be loaded. You killed all enemies. Level 4 couldn't be loaded. So let's look at this part. It says, go to File, Build Settings. I'm going to stop playing, go to File and Build Settings. And look here, we have scenes in build. Right now we have that default sample scene. That's not what we want though. We want all of our levels in here. So I can hit the Add Open Scenes button. That's going to add level 1 because it's open. But I can also go to Project View, go to my Scenes folder, and drag level 2 in. And now level 1 and level 2 are there. So if I go to File and Save Project, and it's very important that we do this, go to File, Save Project, because otherwise your build settings may not save. That's the only real way to force them to save. Now that I've got that done, we can hit play, and we should be able to load into level 2. So we kill this guy. Look at that, just like a pro, and we loaded into level 2. And my level 2 design isn't the best, right? The guys are already kind of falling and dying on their own. But I hope you get the idea. And now you can go through and just create as many levels as you want. Just make sure that you add them all to that build settings. And then have your friends or family or whoever play through it and hopefully have a big blast with it. One last thing that you might have noticed here, by the way, is that cloud poofing particle just keeps going. To turn that off and change it, go to Assets, go select your cloud particles, and uncheck that looping option right there. I left that on, so our cloud was just constantly replaying its particle every 5 seconds. So since this is on a prefab, we won't actually need to change anything in the scenes. We just make that one change there. All right, I hope this is a really helpful video for you and helped you make your own game. And I think that you should be able to build quite a bit off of this. Just keep adding in new enemies, adding in new obstacles, make some fun levels, and just have a blast with it. If you're really interested in this kind of stuff, I'm going to be doing another video where I follow up on this and dive into how to keep things nice and clean, how to really refactor your code, make it really extensible, and make it so that we can build out an even bigger project without things falling apart. And we'll talk more about performance and what we call the solid principles, just clean game code. So if you're interested in that, make sure that you're subscribed and you hit like and all that stuff. Also, if you're interested in more in-depth training, I have a couple courses available. I'll have a link below. You can go check them out and see if they're something that fits for you. Otherwise, just enjoy building games, keep at it, and have a lot of fun with it. It's a great career and a great hobby. I highly recommend it for everyone. You can have a blast, and you get to make things like this for work and fun. All right, thanks again. I really appreciate it. Again, don't forget to like, subscribe, and share and all that stuff. And goodbye.